Det var ett nytt ord. Mono recording that emphasizes sound coming from the front of the camcorder. Men det är ju bara för den inbyggda micken, känns det som. Men det kan ju finnas något... Okej. Jag kollar manualen, ja. Nej. Jag tänkte väl gå ut. Eller jaha, nu försvann han som skulle sitta här. Ja.
Jag kan fånga honom.
Ja, eller låt honom luncha först så kan jag luncha lite senare. För jag är inte jättehungrig än. Ta slut. Oj. Vad finns det för mackor? Är det one sort fits all, eller?
Ja, gå och ta 2 stycken så kan jag kan vänta här så länge.
Nej, men jag har hörlurar. Ja, det där är mina. Men jag har flera hörlurar.
Okay. Yeah. Wrap it up. Yeah. Yeah, we have time. Yeah, yeah.
What a wonderfully well-disciplined conference. Please welcome our next speaker, Mr. Brandon Mercer.
Thank you. Well, it's great to be here. I really looking forward to giving this talk. It feels like in all the discussions that I've had with everyone, like we're all on the same page on so many things. And we all know the answers to so many things, and yet like we struggle through them like over and over again. And but anyway, I hope that like by us publishing these talks on YouTube that other people can get this information, and managers can get this information, and people who are not technical, like bosses who may not be technical, can get this information and kind of absorb it and adopt it. I know talking to you guys, you're just going to look at what I say and say, yes, absolutely, because we've talked about it like for the past however many hours and days over meals. So anyway, this talk is about why we're using OpenBSD in the healthcare industry. And so a little bit about myself. I'm an application developer. I write web applications, I write APIs, I write file processing for not big data, because I refuse to use that term. But most of what my company does is we take data and we process it into other forms, and we use it to do our business purposes and all that kind of stuff. I'm also an OpenBSD slacker. That should say slacker on that slide because I'm slacking way too much and stuff. I mainly play around with like the ARM stuff, and after you get through the boot blocks, you don't want to do any more work on ARM because it's really painful. So, as another side note here, I'm not really a sysadmin, so I'm not really a consumer of these BSDs and such. But anyhow, so. The background for this talk is that we hear a lot of great information about big companies using these BSDs to do stuff. Google and Netflix and Facebook, and they have a lot of resources, they have a lot of great talent, and they're doing really great things with BSDs. And they say, oh man, we need 10 million packets per second, and somebody goes in the kernel and he says, yeah, let me see what I can figure out with this. And he makes things work better and operate faster. So I aim to talk about how OpenBSD is relevant to a small business. Maybe you're not operating with 20 engineers. Maybe you have a couple. And maybe you're just a consumer. Maybe you don't have a kernel hacker on your team who can address these types of problems. Maybe you're, maybe you're just a small organization who thinks, we aren't a technology company. We can't possibly figure out how to run something as complex and sophisticated as OpenBSD. And that's what we're going to talk about today. I kind of want to dispel some myths and misnomers that float around the internet. And hopefully, we're going to talk about some of the more political problems that face these types of situations, like enterprise solutions in an enterprise company. And when you aren't that, or you are that, what challenges do you face and all that kind of stuff. So most of my work is considered in a web application development. So we have to iterate very quickly. We have to move very quickly because our stuff is facing publicly and it's changing all the time. So I want to give you a little bit of background about the healthcare industry in the United States. The company that I work for is a third-party administrator for companies who provide their own health insurance. And what that basically means is, as healthcare things go, we're in there and relevant, but we're generally probably like one of the more removed things, but we have all the important data that comes every time you go to the doctor's office or anything like that. So you go to the doctor's office, your insurance company gets billed in the US, and then all that information comes to us because we administer your plan, all that kind of stuff. The company is regulated, so we have like regulatory requirements that we have to meet. We can't just throw OpenBSD in there and say, hey, no, I know that this works, you have to accept that. There are some regulations around that, and we're going to talk about that later in the talk. So we have to kind of be aware of that. And it's good because there's room in their lingo about allowing other things, but yeah. You'll see. So the company that I work for, it's strange because we're not considered a technology company, but our technology is really allowing our clients to do things that they like to do, so it's important. And so a little culture thing here, like where we're fitting. So we're pretty relevant in the healthcare space. We are one of those people who is working with the big networks, and they like what we have. They actually sell what we have, but we're not big enough that we like make our own rules. We're not we're not like setting the standard here. We're not able to say you need to use this because we know that this is right. So it's kind of like in the middle ground where we have visibility and integration with these big players, but we aren't telling them how to do their jobs. And again, I mentioned earlier, our technology is vital to our success. It's kind of a strange thing because you don't think about a salesman in a healthcare industry coming in a suit and proposing to a client, I'm going to sell you our product because of our technology. Like, you'd be laughed off the stage. But it's strange. We're in a unique place. My boss is selling our technology stack because the big network players, they cannot do what we're doing, and they know that, and they admit that to us. And so we have like this flexibility happening that is allowing these clients to do things that they wouldn't be able to do otherwise. So it's important. I want you to understand that this isn't like my home blog, and it's not quite like 10 million packets per second content distribution networks. So the company is small. This is not like, 10,500 people. We have a couple full-time developers who basically write our core technology, myself included. And then there's other resources in the organization that split their time, mostly doing other things. So it's kind of strange because even though we have like a small team and like we aren't really like the cream of the crop, I guess you'd say, when it comes to developers, we have really difficult requirements to get things like managed. We have very small amount of resources and very big scope of work. Does anyone relate with that at all? Okay, you do. Like, all right, good. So So at least I'm talking to the right people about these types of problems. Like, it's just different because you don't have a team of 5 people addressing a single problem. You have a team of 1 person split into 20 different problems. That's basically where I want to go with this. So the reason I'm telling you all this stuff is because it's relevant to the problems that we face. Like, as people who work in technology, I think I'm very happy with how we've been able to come from the place of not enough resources and big problems, and we've been able to address those problems. So that's why I'm talking about all that kind of stuff. The development requirements are a little bit crazy too. You know how most people are like, if error equals boom, ignore it? In healthcare, you don't do that because like an error means something. So basically everything we do, there is no like, well, what's our main path if everything works, and then what's the error path, and then what's the other path? Like in this type of industry, the error means something, and the other path and the other path and the other path are going to make up like the bulk of your the bulk of your claims processing. So everything I just explained to you about the healthcare industry, you might have like an idea in your head about the healthcare industry, and I will say that that's probably true, and I'm trying not to pick on healthcare industry too badly. We have some things to overcome, and we have some improvements to make, and I think it's probably not unique to the healthcare industry, but basically, when people go to change things, it's met with just unmerited resistance all the time. When people want to improve something, it's met with resistance all the time. So that's changing, and it's kind of a good thing. We're seeing it like locally around me. I'm seeing companies adopt new technology, voice over IP phones, and improving healthcare using technology rather than like making it more bloated and bigger. All right, so we have in-house software that we use to process all this data that we get. So basically what happens is we have all these trading partners that send us files. So there's going to be medical claims coming into us, prescription claims coming into us, eligibility information coming into us, and all this other stuff. And we have to process that data very quickly and then get it into our specified format for our claim system to keep the claim system happy. And of course, the claim system has like one spec, and I can't like give that to all of our clients and say like implement our spec, because guess what happens? Our clients can't do it. And they don't have the resources, and that's why they're paying us. So that's our value add in the whole place. So we process all these files, we take what we get, we translate it into the spec that the claim system can load, and then we have a web application that basically takes all that information we pulled off the claims and all the information we pulled out of the eligibility, and it presents it to the people who actually like do the work. This is largely important to like the products that we have, because we're doing special things. That's how we expose all that stuff. All these special like, hey, pay my claim this way. All that stuff happens through that web UI. We're putting things in files that probably don't really belong there, but that's how we provide these products. And we, anyway, there's a web application. We have also Java applications that normalize all this data down too. So there's big light dimming processes that run. Does anyone know about Java and light dimming processes? Like you run the JDK in VMware and it like crawls down and brings every other process you have to its knees. And then also we have a Perl version that also processes EDI. So anyway. So a little bit more about this stuff and how it fits into the company. This is core product for us. Like, if this stuff doesn't work, we can't do the thing that makes us all of our money. So this isn't just like, my boss let me play with a little wiki and run something. This is one of those things where this is how we make all of our money. And yeah, it's very very, very critical to the company. Every piece of data in and every piece of data out goes through these applications. There's no exception. All the RX stuff, the prescription stuff, all the medical claims, all the stuff goes through here. And these processes, well, we usually get process and translate a couple hundred files a day. If you do the math across 9 hours, it's pretty intense, the workload. And of course, everyone says that performance is not a requirement until you run something, and then all of a sudden it's this has to work. And when you're running a couple hundred files a day, obviously performance is an issue. And then it's also I alluded earlier to the fact that development resources are limited. So are our technological resources. We can't just allocate 16 gigs of memory and a bazillion CPU cores because we just don't run that type of infrastructure at the company where I'm at. So roughly, we'll round this, several thousand transactions a day. So it's not massive, right? This is just this is where everything fits. And again, I'm emphasizing importance. When we plan our disaster recovery and stuff, this stuff has to work. So we can't gloss over it and be oh, it's that little web thing written in Perl that guy with the beard wrote, although I'm pretty cleanly shaven. So what was happening 8 years ago when I started working there, we were moving to a virtualized infrastructure. And we had a sysadmin, and we faced a lot of problems that no one else has ever seen before, and they were very unique to us. Does anyone sense my sarcasm on this? Okay, so we faced the same thing that everybody probably faces. When things would get upgraded and updated, it was very disruptive. I can't tell you how disruptive it was. And it consumed all the time that our very limited resources had. We had to configure a Linux machine to add packages from some mirror just for basic stuff that you'd need to do your daily job. And the deployments were horrible. The developer would go to get his code in production. It was oh my gosh, you would think you were trying to put a man on the moon, and I don't know. So we had machines with all these root processes running, and we'd deploy these applications, and they'd be this web application does not need root. This file processor does not need root. And he'd run with root 300 or 400 times and all that kind of stuff. And it was horrible to try and start up an application because these startup scripts would just grow and grow and grow. And it's several hundred lines of stuff that you have to maintain when you don't have time and all that kind of stuff. It seemed to be the norm that the only updated, or the only software you could get was out-of-date software. So it was hey, we're on 1.4.2, and they'd have 1.1.x, and you couldn't get to the next thing because it just didn't exist in some yum repo, and then you'd have to go do it yourself, which is possible, but not where we wanted to be spending our time. We also had a lot of issues with VMware tools. Basically, VMware tools, yeah. They do, and it's a debacle. I don't know, everybody's hey, do you have VMware tools installed? And we did, and it was the wrong version. So instead of making it not work well, it makes it work horrible, right? So if you run the wrong version of VMware tools, you may as well just run the thing on a BeagleBone Black. So it was very bad, and then you couldn't get them updated regularly, and I don't know. It was very, very painful. It seemed I was the only one in the room saying, VMware adds more work to the amount of things that we're trying to manage. And I was the only one saying that. And everybody said, no, it simplifies because look. And I said, you've added another thing to maintain. You have the same machines, and now you have another thing around it. So anyway, that's kind of where we were. It was very, very painful. So one of the things that I took personal was when we went to a vendor and we said, we're looking to you to provide updates, right? You subscribe to Red Hat, and they say, we're going to give you downloaded packages for anything that's vulnerable, and we know that it's vulnerable on your system, so we're going to ship you this thing, and then they don't do it. And they don't do it in a timely manner, right? Hey, this huge thing that you got to turn off a service comes out with a vulnerability, and they don't have a package for a day and a half. Now, I know that seems like stellar time now, but way back 8 years ago, it took a lot longer. And it also seemed like it was happening very frequently. Several times a week it seemed like it was just, boom, here's this thing that you have to get that you should have taken care of 3 days ago. And I know it's a small scale, but the number of vulnerabilities and patches and reliability fixes seemed to be very high to me. So when we ran this stuff in production, we were running on like Red Hat in our like premier production systems, and we were using CentOS in dev and test, and that doesn't work. So if anyone has done that, you know, like when you try and add like a repo to your CentOS machine and you get like a tool that you're using in development, and then you want it in the Red Hat network package management thing that I've already forgotten because it was 8 years ago, it's pulling teeth, it's horrible, and it doesn't work. We had some disconnects too, like basically we'd set up the environment in one machine and we'd spend like hours and hours getting it right, and then we'd go to our staging environment and we couldn't recreate that same thing for some strange reason. It was painful and it was arduous, and we said, this is a solved problem. Like every boss out there says, this is a solved problem, why doesn't this work? And it just doesn't. I don't know why. I'm not going to do the analysis on it, but whatever. And if you know about how Red Hat's package management works, they have like a dependency on Python, and they did not want to like move from that. So if you needed Python to be on that machine that was newer than that, you broke their package management all the time, and that's kind of like where we had issues. So this is what the process used to look like. Like the updating and keeping up to date of these machines, right? Because we have like 5, 6, 7 machines that actually run this. We don't have like, automated scripts and like, what are the tools that we use to keep like hundreds of machines updated now? Whatever it was, we didn't have those, and we still don't use them today because it's a small number. I advocate simplicity, so don't do that. But what would happen is the sysadmin he'd like SSH into the server's root someday, and he'd be like, oh, I think I should run yum update. And he would run yum update, and he'd be like, oh, well, there's several packages up to date. I'll go ahead and upgrade them. And do that in a production environment. And then when we go to process the next transaction, the JDK was out of date and had some backwards incompatible breaking change, and then our apps didn't start and all this other kind of stuff. And there was no easy way to like undo that entire mess. So then the developers like packed on this huge I have to go change and make up all this time that he just destroyed for me. There was a huge disconnect from the way things ought to be, which is what I'm going to talk about here in a little bit, and where they were. And part of it was cultural and part of it was technical, and it was just a wonderful marriage of destruction every time. So, why did we start using OpenBSD? This was not someone with a solution trying to apply it to a problem. And I want to emphasize that. Like, sometimes we say, this is a good thing, start using it. And we don't have any justification for it. And this is really, really important. When we started using this, it was in response to a problem. And it actually fixed something that we could quantify. And this is really, really important. Never start using new software, never implement a new technology without understanding what it means to use it. Don't do it. What happened was I rewrote a core business application in Python, and I know we probably all love Python, but whatever. It was doing like string manipulation, and I said I can do that in Python pretty easily. So anyway, that Python tool used a library that required Python 2.6, and we could only get 2.4 in Red Hat. And after the sysadmin broke the production machine like 17 times, I kind of piped up and said, listen, I've been writing all this stuff in OpenBSD. We can run 3 versions of Python on here and no one dies. And so, not to say that you couldn't fix the problem with the package management, and not to say you couldn't run more than one version of Python on Red Hat, but the easier path and the one that my boss chose was, well, why don't we use what you're using in development? And that was a great key point. My boss trusted me, and it actually paved the way for a lot of other great improvements that just sort of like were observed over time. It's obvious, like SB said, duh, you just picked OpenBSD and it worked. But to someone who doesn't know OpenBSD, they don't know what duh is, and that's what I'm going to talk about. And that's why YouTube, watch this if you're a manager, like watch this video and learn the duh. So we had our first install of OpenBSD, and it's been out there for 6 years, not upgraded or anything. And I think that that's a little unfortunate, but we have made improvements around everything, really. So generally, when you talk about OpenBSD, everybody thinks about it in a perimeter device, right? Because routing and firewalls are something that it does really well. And I love those stories, and if you guys are doing that, keep deploying OpenBSD. It finds the weaknesses, it finds the strengths, people get exposure to it, you have to integrate with other systems, Cisco's and Sonic Fails, and all those types of technologies that are commercially available. Keep putting it out there. We improve every time someone puts a new installation out there just because it gets some exposure. But anyway, what we're doing, we have put a lot of stuff on OpenBSD. I said we process all of our medical claims on it. We actually now have a public-facing API that our government hits to do eligibility inquiries. So this was like a mandate, like we had to provide this service to them. And so now that inquiry happens on an OpenBSD machine. We've got the business critical web applications that I talked about. Those all live on OpenBSD now. The web application used to run on Linux, and now it's running on OpenBSD. All the file processing now runs on OpenBSD. So a lot of people out there say, like, OpenBSD is slow. We can't run an application on it. It's just a firewall tool. That is a lie. Okay? And I don't want to say like another empty thing on the internet. Whenever you deploy technology, you have to quantify everything you say. Slow means nothing to someone in technology. If I tell a FreeBSD guy that this is slow, he's going to wonder why it's less than 15 million packets per second. Just, like what I'm saying, you have to quantify what you're saying. So when someone says OpenBSD doesn't make a good application server because it's slow, what does slow mean? And in this particular paradigm, it's plenty fast enough. It processes thousands and thousands of medical claims a day, no issues. No blinking, no problem whatsoever. We also run some scheduling and automation software that was developed in-house. This is kind of like a neat thing. We run cron for certain things, but then we also need to like have visibility into jobs that someone can like get access to from a web interface, because all these processes run across several machines, and we kind of want to have a central place where you can go like see all this stuff. So we have this application deployed on OpenBSD, and basically when it starts up, it calls into the database and says, what are my jobs, give me my work to do for the day, and it schedules those tasks out and all that kind of stuff. We have a unique encryption-decryption application. Basically, every file that we get is PGP, GPG encrypted from our trading partner. And I don't know if I'm supposed to say this, but it was found in an audit one time that the keys were stored on a Windows share, and that they were also installed on an application server that was processing files, and they were also installed on someone else's desktop who processes files. And come to find out, lo and behold, having your private keys stored in all those places is like not acceptable at all to any regulatory body or anyone with a pulse, or basically anyone. We didn't really know that it was a problem, and then we kind of like identified the problem. We started to come up with a fix for it. So we store our keys there. I think it's important to have an operating system that you trust when you are talking about crypto. The last thing is that we run our database on OpenBSD. And again, there's misnomers floating about on the internet, like OpenBSD isn't performant enough because FFS this and slow that and locking this and MP this and all these other things. No, we put our database on OpenBSD and we dump tons of transactions in it at a time, just hammer it, and then we report on it all day long, and it works just fine. And for the record, it's not MongoDB sharded out and all these other things. It's just a single Postgres instance. I know, +5 heckle points for that one. So, but it's just a single Postgres instance that we run, and it works very well. So if you guys are not running OpenBSD for your databases, like, run it and see what happens. It could be web scale enough and cloudy. So now I'm going to kind of talk about like the technology stack a little bit more, because I think this is really important to a theme that I'm going to try and bring together here at the end of this talk. But I really love simplicity. I think it's a design feature. I think it's a goal that everyone should have. When we build applications, it seems like you just pile on thing after thing after thing. So anyway, I'm getting ahead of myself. But our web stack in 2015 is an OpenBSD server running a Go web application with Postgres in the back end, and we just have static HTML, JavaScript, and all that kind of stuff. And basically the way the application works now is the Go application is not a REST service, it's like a JSON service, because REST doesn't actually fit into all the things that we do with it. You can't like search for an SSN with a GET request. And if you don't know why, come see me afterwards. We'll talk about it. But anyway, that's kind of like how we do things. We don't have LAMP anymore, and if you use PHP and stuff like that, well, this is what I'd offer to you to simplify your problems a little bit. Typically, when you see a web stack, like it's kind of heavy, right? So you install these packages from ports, and then you grab Node and you have another package manager for your next tool that you downloaded. So now you've got a package manager that installed another package manager that installed a bunch of Node modules, and then you occupied 400 megs of your disk, and I've seen it as high as 2 gigs of your disk of just JavaScript to produce like a static hello world application. I won't tell you all the details about that, but anyway, once you have all that stuff installed and you've like downloaded all of it, you have your environment, and now you can write hello world in JavaScript, and you have like a bazillion new JavaScript tools to learn, like grunt this and bower that, and you're grunting by the time you're done with it and all that other kind of stuff. I don't advocate doing this. I'm happy that there's like a lot of innovation in the web world going on. There's like Docker and all these things, but don't use them, please. I feel bad saying that because somebody put a lot of time into that and it solves their problem, but I think that we can do better. Like I really want to think and believe that we can do better. And one of the things about OpenBSD that I love is they always start pulling things out that aren't needed anymore. Get it out of your source tree. We don't need to be looking at it. It just doesn't belong there anymore. So one of the things that I have spent a lot of hours on is simplifying every application that we have. So the Java application that I talked about earlier that dims the lights, and the web, like it takes like 5 minutes to start up and like process a file that takes like however many seconds, and then it's done. And the same thing's true with like the web service. Like in Java, you like fire this thing up, and like 45 seconds later, you can get like stop getting 503s. So anyway, what we're doing here now is we have a single JavaScript file. The development environment to get like Vim and Git and Mercurial and a couple other things is roughly 100 OpenBSD packages. And that number seems high to me just because I only installed like 4 things that I needed to do my job. 1 JavaScript library and 1 tool to manage. So this is how the web stack actually looks in our new versions of the application. It's super simple, super concise. This is what web scale looks like in 2015. This is web scale. And it's web scale because you can scale this far, far, far greater than you can scale this. You add a new developer, and it takes a day and a half to set the environment up. You add a new developer, and you have to bring them up on all the complexity and all the tools, and then you're training him, and then you go to try and hire someone, and what happens? Do you have Bower? Well, he's out of the running. Do you have Grunt? No, I don't know Grunt. Do you know how to minify JavaScript? Well, I've only used this tool, and then there's this other tool. So the requirements for finding capable candidates get very difficult. I think this is like counterintuitive. A lot of times managers say, well, we can't use that because, what? I'm not going to be able to find a resource who can do that. And so doing like the trendy norm thing, which looks like this, actually creates you a lot of pain. So in this case, simplify your web stack. This is better than any web stack I've ever worked on, and I've been doing web stuff for like 15 years. It's really good right now. Don't adopt the new things unless you absolutely have to use them to manage your stuff. I mean, there's cases when it makes sense to have config management in a config management tool. But if you can do it in a little Git or Mercurial repo and then push them out to 5 machines, that's the way to do it, because there's less stuff to go wrong. There's less stuff to manage. So the application today, the really great thing about it is we can test it super easily. The Java application that like dimmed the lights in the Perl script, the developer was logging into the machine and like updating the Perl in production and not tracking any of the changes in source control. So don't do that. The application today is really, really, really simple. And I've worked very, very hard to get it that way. If this talk seems like I'm talking about nothing, it's because I have worked for the past 7 or 8 years to take this huge monster and pare it down to nothing that still accomplishes the same goal. The other thing, too, that I think is really important is for any kind of software that you build, make sure you have performance benchmarks. It's really important to know when you do an upgrade if there was like a 15% increase in the amount of overhead that you did. Does your network increase? Does your CPU spike? Does your memory utilization change? I guess performance is the wrong word. Get metrics of how your application operates. Know how your application operates so that when you have to fix it, you know if you're breaking other things or not. Actually, I want to show you one thing here. No, it's not important. It's just testing. We'll just test it on Friday afternoon when we deploy it in production. So how are we today? I know these slides are thin, but again, going along with my simple theme, the talk is where the value is. So I talked to you earlier about the disconnect between like a developer's workstation in production and like what the gaps were and what the holes were. So when we change our operating system, when we do an update for whatever reason, let's say OpenBSD fixes some issue or improves something, the idea here is that I start that initiation on my development workstation. I grab a snapshot. It's super easy to do. It takes 5 minutes. I test it out because I can test every application that we have right there on my local machine. And then if everything works, you know, like it needs to, we promote all that entire environment up to the staging environment, and we can test that. I know it's so simple and makes so much sense that it's like duh, but a while ago, SB alluded to duh, and why weren't we doing that? 8 years ago when we were building a brand new infrastructure, you would think that that would be one of the first things that they would talk about when you implement a new infrastructure is like, let's talk about the promotion process, let's talk about the new updates process. Never happened. Created headaches. It was disruptive. So anyway, when we have updates to packages that are part of our core service, it starts on my workstation with a snapshot and download packages or test a port or test a patch or something like that. And then I alluded to deployments a little bit ago. And this is what I just said. Yeah, so when you follow snapshots, it's a really good thing to do because if you don't track something frequently enough, you have forked. You're a little divergent. And so I've tried to get us to a point now where we're not going to have another machine that 8 years later we can't upgrade because they went through some flag day or something happened that we can't get back and trunk with them. So I follow snapshots on the development machine very, very consistently so that I have a good pulse of what's going on with the tip of the project. And if you've ever listened to like a Googler talk about like WebKit and Chromium, they say that they have to do that, they have to track that daily in order to keep up with the changes. And we find the same thing. If you go on XP and then you like don't upgrade to the next thing and don't upgrade to the next thing, by the time they're like deprecating XP and you're trying to figure out how Windows 10 is going to fit into your licensing scheme, it's hugely disruptive. Don't do that. Like, it's horrible. In web environment especially, like, you have to stay on good software, and you have to stay on current software, and you have to be able to do that. You can't use a tool that doesn't allow you to do that. Oh, and like package management, rather than like yum repos and all this stuff, I just pull down the entire mirror in case I need to like test something or build something later on, and then I host that up so that the staging environment and production environment can get the same packages so that we can all just run the same stuff when it's up to date. Very, very simple. And then, so we actually have two strategies at work. We track stable for our database and that encryption thing because I don't like to change those as much. And it's something where those two take a little bit more effort to do upgrades, and they don't need to be upgraded that often. So basically, that's what I do. I just track the stable release for those two types of machines, and then we use snapshots for everything else. And it's good because you get visibility, and you know what's going to happen later on in the release for the machines that you are tracking stable. So I think it's important to do both. So I've built this infrastructure and built this environment, and I'm very happy with it. And I've talked about this the entire talk, and it's super important. Run as few dependencies as possible. It seems obvious, but if you're installing several hundred things from ports and packages, now you have 700 intermingled things to maintain and update. So when something is broken, do you have to recompile 20 applications to link against some new library, or do you have to like do it once? This is important. Like in web stuff where you have limited resources and there's constantly things to fix, the less stuff you have to fix, the better. And generally speaking, the less crappy products you have running in your company as well. And the other thing too is like, when we update stuff, I only use packages and ports. I don't like compile stuff on the machine itself. When you go to upgrade a machine and you're like, hey, I had this thing running on there. Did you? No, I didn't even know it existed. It like wasn't, I could have no idea what was installed in that machine if you compiled it from source. Like you look in some home directories and there's like BAE, and I'm like, what the hell's a BAE? Oh, backup exec, okay, you know. And it's not a package, it's not a port, it's just something they tried to spin in. So yes, OS installs, fast and easy. There's nothing to figure out. Package management, super easy. Jasper is going to talk about your company doing, providing binary updates and packages, or M-tier. Oh, okay. Never mind, he's not going to talk about that. I manage it myself, but there are companies that provide that service that actually do a good job at it, that actually produce binary updates when you need them. So anyway, pick the right tools. If you need to, like, if you choose a compiler that needs 2 compilers to compile it, like, it sounds funny, but I tried something new and it did that, and I said, it's just out of the running. So when you build your application, make it as simple as you possibly can. Don't pack in features for the sake of competing with features. It's just not helpful. That poor code is going to be maintained for like 8 years by some guy who doesn't, like, I don't know, by me. Don't do it. All right, so we have a few minutes. So we started using OpenBSD, and it's like evolved into this great thing. And my boss is fantastic because he gets technology, and he trusts me, and he empowers me. But there's also like regulatory bodies who don't trust me and don't give 2 hoots what I think or care or say. And so we kind of have to like fall into that. So I'm not a lawyer, and I'm not going to guarantee that this is right. Like HIPAA may come back and be like, you guys can't do that. So, but anyway, they have this thing that says any machine that contains electronic personal health information has to fit into these requirements. You have to have audit controls. You can't log in as root. You have to provide like integrity checks, all this kind of stuff. And it's a very like cookie cutter, like duh kind of thing. Like you have to meet these requirements, but they're in there. Somebody was asking about, like, on the desktop machines, what does it mean? Like, can we still run Windows XP? And they said, yeah, you can still run XP, but not for any machine that's doing these critical pieces of information. So OpenBSD satisfies these requirements. We have a regular release cycle. There's patches being released when things are vulnerable. One of the few, I think, that disables root by default. So if you're running a Linux or some other thing, yeah. SSH, this seems kind of obvious, but SSH is used in my company to log into our claim system. So we have literally like hundreds of people SSHing every day. And the version of SSH that we have is scary how old it is. It's very, 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 very painful. And so another thing too, like that my boss loved about OpenBSD was this, the daily security check. What binaries have changed on your machine? Have you added new users? Have you added new groups? He's like, I didn't know this exists. So we do this like by hand in every other machine that we have. Like, hey, here's the change management form. Well, how do you know that that's what happened? Because the change management form said to do it. And here, like, who's run the daily security stuff in OpenBSD by a show of hands? So like okay, good, that's better. Okay, good. Yeah. And so you get this email that kind of details, and you can hand that in with your audit, and you can say, we're keeping track of this stuff. We only added 2 new users. We only have X users, all that kind of stuff. Yeah. So why does all of this stuff matter? We come to these conferences, and we talk about this stuff, and people are using great tools. And sometimes these great tools, people are creating these great tools. Well, what happens if they just sit on the bench, right? Like, we joke about cars that are like trailer queens because you don't drive them, but they're like amazing. And so we have tools that are amazing. We need to be using them. Like, start using this stuff. Find the weaknesses. Find how it fits into your experience. Find how it fits into your organization. Build software on it. OpenBSD as a whole, the 3 sysadmins that we've had in my tenure there have really enjoyed administering OpenBSD, partly because there's good documentation, there's less to do, the tools make more sense, all that kind of stuff. We had a guy, and he was trying to configure like 2 default routes on Linux, and there was like a shell script, and then ifconfig this, and something that, and route this, and it's just far more easy in OpenBSD. And what's that? Yes, exactly. So Linux really has diverged greatly from a lot of things, and I think the user experience is probably the most divergent, in my opinion. So the other thing that we don't have anymore is we don't have 400 processes running as root. I know, it's obvious. This obvious stuff that we just don't do. So now my company is doing it, and your company should be doing it too. When you start up an application in OpenBSD, there might be a small process that needs root, and then the rest of the application starts up with a non-privileged user. You should be doing that. You should make your web applications start up with a non-root user. You should make them start up on a non-privileged port, and that should be like the normal. Again, it's obvious. Do it. Just start doing those types of things. Look at your process tree and your servers, and I have a Java application with 700 whatever processes all running as root. So one of the other things too that I think is valuable, or is valuable to me, is OpenBSD publishes OpenSSH, and we have so much known broken crypto on the internet these days. And OpenBSD is kind of like turning this stuff off. And it's really important to turn off stuff that we know is broken. It's really important to stop using stuff that we know is bad. Like crypto used to be like, well, do the mathematicians agree on it? Do the crypto experts agree on it? Let's let it be vetted for a while. And if it wasn't like 100%, people wouldn't even adopt it. And now we're in a place where we aren't even disabling stuff that we know is easily exploitable. Why is that? 2015, like, we have the most information so quickly at our fingertips, and we're still running things that we know are easily exploitable by default. Don't do that. Stop doing that. Use OpenBSD, use OpenSSH that they build. stop using known broken crypto. One of the fun side effects from us running OpenBSD in our organization, I told you that a lot of big companies transact with us. Backup software, SSH software that our end users use. We have this, thing with the GUI that transfers files around over SSH. We have to turn on cipher suites that we know are broken to make that stuff work. You call that vendor and say, you can't use this stuff, it's broken. And you may have to beat them up for a while, like Salesforce. I won't say Salesforce, but eventually, months later, they have to enable TLS 1.2 because the other ones named SSL are broken. That has an impact, right? Because enough people complained and said, look, you can't use this stuff, it's broken. So anyway, one other thing I want to touch about, and I know that I'm right on time, is when you build web applications, random number generation is really important, and I think it's overlooked. You'll hear a lot of people talk about random number generation isn't important, or you can never truly have random numbers, so why would you aspire to it? But when you're building a web application that's sending back nonces, and you're building web applications that are sending back session information to a bunch of things, it's really, really important that you don't exhaust that, especially on a virtualized infrastructure. And I was going to have some really useful information about that when you have a single host that has 20 VMs running on it that's all pulling random number generation, all coming from the same CPU, but I don't have it, I'm sorry. These simple startup scripts, I know this is crazy easy, and I thought I was going to have a startup script in here, but you can, in 5 lines in OpenBSD, deploy a new web application, say which user it runs as, give it the binary, and then you're done. I know it sounds obvious, but when you're administering a system and you're trying to run 5 small services, it just simplifies the pain so much. So, and that is it from me. Does anybody have any questions? Yes?
How do you do backup?
The question is, how do we do backups? And right now, we're using Veeam to back up our virtualized infrastructure. And there are some problems that we had to work through. Veeam is not terrible from the user experience standpoint, but it is terrible from the standpoint of it made us enable broken cipher suites and that kind of stuff. And it's hard to set up SSH certificates or keys rather than username password, and they want root. And we had to install GTAR. But we found that information out because we put OpenBSD in that environment. So anyway.
So you're taking backups of the full virtual machine?
That's right.
Okay.
Yep, the full virtual machine is being backed up. That was the question.
And for that you need the VM tool?
Yeah, so I didn't really put this in my conclusion, but I talked early on about the VMware Tools debacle. We do not run VMware Tools in production on several systems, and it works fine. Just as a side note. So anything else? Does anyone else? Yes?
How do you do high availability?
High availability. So the question is, how do we do high availability? And the answer to that is, we've been running in a data center regionally, so it's close to us. And then we also have another data center that runs the same stuff. So basically the high availability piece is that we have 2 separate data centers that we can hit either one at any point in time. Yeah, I probably should have spent a little less time talking about healthcare and a little more time talking about the application deployments. But the web application runs all the time. The hardware and the virtualization infrastructure is what handles the high availability. The application itself just isn't very stressed, so it's less likely to be down anyhow. So, yeah, thank you.
Have you managed to find a tool to clone the virtual machines automatically?
So the question is, have we found a tool to clone the virtual machines? Yeah, and when we do upgrades and we do that kind of stuff, what we do is we take a snapshot of the VM, and then if we're doing an upgrade, we will start up that virtual machine and do the upgrade on it and find out if there's any brokenness, which usually we don't have to do in production because we've already done it in the development environment. And then you just, if you need the old machine that you still have running, you have it there. Otherwise, you just start pointing traffic at the new snapshot that you took.
But if you need to multiply, make it 10 clones of it,
Yep.
can you automatically
Yes. So the
auto-install or something?
yes. So the question is, if we have 10 instances that we want to clone and replicate, can we do an auto install on that? And the answer is yes. we are not there. Like, we don't have that many machines. We don't have that many like instances. So again, this is really for like small scale. You know, if you wanted to have 10 of the same machine, it's probably about 50 minutes to install all 10 from scratch. Honestly, like, if you started them all at the same time and wanted to set them up all the really hard way, it's less than an hour. The tools that make that available, maybe you download them in an hour. I don't know, like, I haven't had to do that. But I don't think that there's really a lot of work to do 10 separate installs and use the site packages to install the configurations for your application, that kind of stuff. Good. Anything else?
Any plans moving to Beehive?
Beehive. So the question is, do we have any plans to move to Beehive? And the answer is we have something in OpenBSD coming called VMM. And VMM is a hypervisor as well. And Mike Larkin is working on that. And I can assure you that when we start using that, or when that's available, we will be using that to probably deploy like individual instances for segregation of the services rather than like, you know, deploying 15 things on VMware.
So when is it available?
Yeah, when is it available? Never soon enough, I suppose. Yeah, good. Anything else? Yes?
What operating systems does your company use on the desktop?
Yeah, so the question is, what operating systems does my company use on the desktop? And we use OpenBSD for the dev stuff, which is me. We run like Windows 7 for everyone else. And some XP because we have like accounting software. Yes. Do I see a role for OpenBSD on the desktop? I don't see it happening anytime soon, but do I think it's capable and do I think it's usable as a desktop? Like this right here is your proof. Like we use it all the time. And in an organization, it could be used, but it's generally not. And there's generally like, you know, malware applications that don't run on OpenBSD, and the stuff that manages the malware is what I meant to say. Very good. Anything else? Yes?
Did you need to apply some special configurations to meet the requirements from HIPAA?
Did I need to apply any special requirements to comply with HIPAA? Not as far as I know. Not as far as I know. Yeah, because like these things come up in audits and they don't have any complaints about it. So, I mean, I don't think that there was anything other than a base install that we had to do. Yeah. You had a question? Oh, same question? Okay, good. Yes?
What will you do for backups when you can't use Veeam anymore when you move?
What will we do for backups when we use VMM? Probably tar things up. I mean, honestly, so this is a true like relevant statement here. When we deploy these applications, I do a fresh install of OpenBSD. I was going to demonstrate this today in QMU, but I broke my snapshot before I went to do this. But the base install to a fully running application is like 10 minutes. I mean, 10 minutes. 10 minutes to like do this on an encrypted drive, you know, and really like installing the scripts and deploying the application is really that fast. Okay, I know it's like not Docker speed, but when you're doing things by hand on an X220 laptop, that's really remarkable. Yeah, thank you. Anything else? Great, thank you. Thank you.
is ready. Is this on already? Yes.
Well, looks like it's going up here again. Our next speaker is Honeywell, who will be telling us a lot of things about OpenBSD we didn't know.
Really?
Yeah, well.
So, welcome. I learned we are in Sweden, and to be successful, everything has to be named springtime for whatever the topic is. So, in other countries, the talk's called OpenBSD sucks. It does, but from my perfectly neutral point of view, it's the one that sucks least. So, what is this about? I've been an OpenBSD developer for 13 years now, and for once I'm not really speaking as a developer here, but more like a guy that's actually using it and running into weaknesses and running into perceived weaknesses that you read about all over the place and basically applying a reality check. So many of the points where OpenBSD is strong are kind of well known. Foremost, obviously, security. We also gained a lot of reputation for our networking capabilities. Documentation, always a topic, very well known. Don't clap at me, clap at Ingo, Mercy. And JMC is not here again. One point that I find extremely important that is always or almost always overlooked is consistency. If I'm diving into an area in OpenBSD I haven't been before, I can kind of rely on it's consistent with the other parts of the system, and that's something I don't find anywhere else or almost anywhere else. The list is longer, but this is not what this talk is about. Shocking news, OpenBSD is not perfect. Yeah, sorry. We try hard, and I think we're getting closer and closer and closer, but they're not perfect. So where are our weak spots? When I'm saying this, I have to add the disclaimer here. This is my personal point of view from my experience. It's by no means official. My opinions are just that, my opinions, and they don't matter more than yours. We'll dive into the common knowledge. I hope to raise interest here and start discussions, and I also hope to attract somebody to work on these weak spots, because some of those are areas that I'm not very competent in. Background, where's this experience coming from? I've been running an ISP, mostly on OpenBSD, for more than 15 years. That means running a large number of OpenBSD machines, like we are talking hundreds. Over the last decade, a little bit more, I've been doing consulting jobs. And that saw OpenBSD being used in various interesting cases, some pretty unexpected. I learned that OpenBSD is being used in ambulance cars, for example. And of course, I use OpenBSD every day. My laptop does not run Windows. And it can suspend and resume. So my biggest hurdle with OpenBSD actually is in the file system area, which was kind of the driving point for this talk, because I don't want to work in file systems and I'm incompetent to do so. So our native file systems are FFS and FFS2, basically the same as in FreeBSD, roughly. The roots go back to 4.2 BSD. The descendants even go back much, much further to version 7 Unix. The bits I really, really like about our file systems, foremost FFS, with all these machines and all the weird conditions I've got them in and saw them in, I never ever lost a file system. I think this is very, very impressive. The exception, of course, being the hardware being dead, but there's no way software can work around that. All the other file systems we have are pretty much only there for compatibility, like we don't believe in using others. The bit I miss most are snapshots. Because, well, without snapshots, file system level snapshots, I can't even take a consistent backup because they're obviously not atomic. The other use case that would sometimes be useful is a rollback after a failed upgrade. That's not fun. Not really, actually not really. But if you're pretty doomed. Shouldn't actually be too hard to add this, but well, the bit you hear about most is the whining about FS-check, and there is some truth to it and some whining that's not appropriate. If you're talking about FFS with soft updates enabled, all that FS-check really does is reclaiming free blocks that are not on the free list. So that's not really interfering with using that file system. That could run in the background. Seems very straightforward, but actually isn't. There's a trade-off. If your FS-check at boot takes 3 seconds, who cares? If you're doing that in the background, it might easily take minutes or half an hour or so of degraded performance. So what's better? There's no clear answer here. If the FS-check during boot takes an hour, the story is different, obviously. Background FS-check for FFS is kind of there. I mean, FreeBSD has it. It never made it to OpenBSD, partly because it took so many years to get soft updates to a state where it's actually reliable. But when we imported soft updates from FreeBSD, well, that didn't make things better exactly. So it took years to get that right, and the perception kind of is if we do the same for the background FS-check, we'll have another couple of years until it becomes usable. I think it foremost takes one person to dedicate his time and effort to it. FS-checking on large partitions can take a very long time, like up to hours, and it actually can take a lot of memory. That can be a problem. These very, very large partitions are a bad idea for many ideas, but, well, I do think the problem is perceived as bigger than it is. Waiting for a machine to come back up when the service crashed and the service is important, 1 second feels like an hour, which is why everybody is whining about FS-check so much. But reality check, how often do you actually experience that? I mean, I don't really see OpenBSD crashing, like maybe once a year or so on hundreds of machines. So, not the most important point in everyday use, still it's annoying. And as I said, these very big file systems, reconsider, they're a bad idea for many reasons. On the smaller ones, FS-check usually is so fast that it doesn't matter all that much. Nonetheless, I'd like to see that fixed, worked on. Another point in the file systems is the inode management. Inodes store the metadata like file names and link further storage blocks together. The number of available inodes is decided at NewFS time, like not at runtime. If you're filling the file system with a lot of small files, you might run out of inodes while you still have plenty of disk space available. This is annoying. In practice, I don't remember ever hitting that. Still, it feels wrong because it's too static. A big hurdle I see is partitioning. Everybody's running to the point where you still have plenty of disk space available. One of your partitions ran out. That is pretty damn annoying. So let's compare that to networking, something where I'm slightly more competent in. I don't do ifconfig em0 slice SSH bandwidth 100 megabits, and this is set in stone. It's dynamic, right? So why do I have to do this for file systems? Doesn't make sense to me anymore. Now let's track a little bit. Why do we have it that way? There's lots of historic reasoning. It doesn't really matter anymore. In the old days, you wanted to keep data somewhat close together. We are talking spinning disks. Some of the older guys in here might remember disks being spoken to with cylinders, hats, and sectors. And if you had data spread out, it took a relatively long time to reach into a different cylinder on that other track. So there was a reason to keep data together. These days, it doesn't matter anymore. The internal organization of tracks and sectors and the heads and whatever is completely hidden inside the device anyway. It'll lie to you. It just provides blocks. And that's pretty much the state of art for 20 years now. So the solution to the I run out of space on a single partition, on one partition, and there's still plenty of disk space available, just use one big root partition. That's what Linux does mostly. You don't want that. You do want upper bounds for shares of your file system. You don't want your log files to eat up all your disk space and your relevant production data not being able to be written to the disk anymore, right? You also want guarantees. You want space to be reserved for certain parts of your file system. And a point that I find very important is a clear separation between the system and user data. Your system data usually is easy to be restored because that's the OpenBSD binaries. OpenBSD binaries. Your user data is much more valuable. You do want different mount options for parts of your file systems. There's no point for executables to live in /temp, for example. If there is an executable, you pretty certainly don't want this to be executable. If you put everything in one mount point, you're doomed. What is partitioning all about? We're really just talking about assigning blocks, right? They don't need to be grouped together anymore. All you need, if you want to store a file of a certain size, is acquire the required number of blocks from somewhere, and you should not have to care where they come from. Unfortunately, for now, you do. A partitioning scheme that I'd like really just has sizes as in a reserve and an upper bound for each mount point. If you're running out of space on your disk, well, just add another. It provides a couple of more blocks. Add them to the pool, basically. It's slightly dangerous. That's like RAID 0. You lose one disk and your data is probably screwed. A very valid question is whether a file system should solve this or a layer below. There are solutions for the layer below. They are hard to apply after the fact. If you're doing this, just consider sources of blocks from somewhere. You really carefully have to assess the effects on reliability and robustness, because you're easily going to shoot yourself in the foot. Another point that I'd really like to see is replication. Those running database servers are probably pretty familiar with replication schemes. It's very common to have your master database and replicate to a slave, right? The slave can be seen and often is being used as a kind of live backup. That synchronization does not happen synchronously. You don't want that because that increases latency too much. So it's asynchronous in the background. It's kind of best effort. The implementation of that shouldn't be all that hard. Basically, you write all the changes to some kind of journal and replay the journal on the slave. If there's a conflict, that should never happen if you don't modify data on the slave, but still, if it does, do what the database servers do, bail and ask the admin to fix it. It's good enough. So what about crypto? Does it belong in the file system? I tend to say no. I tend to say it belongs in the layer below. Stefan talked about this. Software crypto actually works like a charm. It solves the problem. So I think that point can be taken out of the equation by now. It all really boils down to more flexibility. The current way of dealing with disks and storage in OpenBSD from the sysadmin perspective is too unflexible. So I want more flexibility. At the same time, I realize that hacking on file systems is not very rewarding. If I screw up in the network stack, you might lose your connection. It might be dropped or something. In the worst case, you reboot and you're fine again. If you screw up in the file system, people lose their porn and they don't like that. So a lot of these issues seem to be solved in another implementation called ZFS. Is that the answer to those problems? Well, I have a clear opinion on that. Definitely not. Why? For me, the discussion is over with the first point. ZFS is not free code. And unfree code, if Kirk and crew had been as careless with licenses as certain other operating systems from our family are today, I'm not even sure we had that strong free software today. So this is a very, very important point. Just imagine this completely taking off, everybody using ZFS, and at some point the copyright holder, in this case Oracle, deciding to execute the fine print of the licensing, we're all doomed. And then it's too late. So please be more careful about your licenses. On top of that, I consider ZFS a giant design fault because it's not a file system. ZFS replaces everything from the IO kernels down to the disk. The careful layering, carefully being worked out over decades, they just throw it out the window and use the kitchen sink approach. And I predict this is going to bite back eventually. Another bit that annoys me personally greatly is the fanboyism about ZFS. So, what about Hammer 2? Maybe, I don't know, if it doesn't become the new GNU herd. So far, we've only seen paper and vaporware, right? Who knows? I think it's promising. Again, I'm not a file system hacker. I'm not all that competent there, so I can't really make a qualified judgment. I think it looks promising. That might be the road forward. It still takes a person or a couple of people putting the effort into it and actually doing it instead of just talking about it like I do. You hear a lot about OpenBSD performance. Brandon went into this a little bit. The common wisdom is that OpenBSD is slow. Last not least, because all the security features and exploit mitigation techniques cost a lot of performance. And this is just not true. It's a lie. Whenever we work on something in the security field or exploit mitigation field, we carefully evaluate the performance impact. If the performance impact is too high, we'll either not use that technique or at least don't turn it on by default. The ones we have turned on all the time come with a minor cost, and this really just is not relevant these days, given the speed of the machines we're dealing with. In some of the very, very many micro benchmarks out there, basically all the benchmarks out there are micro benchmarks. Some of them expose slowness in OpenBSD. Yeah, well, they're exactly that, micro benchmarks. Another set of micro benchmarks will show that OpenBSD is awesomely fast. Again, they are just that, micro benchmarks. The only way for you to assess is to try and check in your environment. My prediction is you won't see any difference to most other OSs. All in all, and in practice, again, experience from 15 years in many machines, we're doing pretty damn well. We're roughly in line with others in most cases. I also think the topic is dramatically overrated because in 99 point how many 9% of all cases, you're not dealing with performance bottlenecks at all. So what are you whining about? This is, in large parts, my dick is longer than your dick. Yeah, exactly. The slowness, you're saying 20 minutes to start a JK. The slowness these days is often in the applications and not in the operating system. In 15 years of running these hundreds of OpenBSD machines, I barely ever ran into performance issues. In the very few spots where I did, I fixed them. So they are not an issue anymore. when I do run into overall performance issues, they are usually not an OS topic, but an application topic. There was a customer recently complaining that his VM is too slow, and after assessing for a while and checking what's going on, how should I say, the solution was select count star instead of select star. Selecting 50,000 votes from a database and adding them up in PHP is never performant. And no OS is going to fix that. So that's where your screw-ups are usually. They are not in the OS. And I always like to ask the question, what's your priority? Do you care about being 1.5% faster? Or do you care about being able to sleep at night because you know that your machine is not going to be hacked overnight? I know where my priority is there. So, SMP. Again, the common wisdom is that our SMP is very, very weak. There actually is some truth to it, and there was more truth to it, because we're making great progress there right now. It took ages, and it's still ongoing. Our kernel still is big-locked in many places, but it's becoming less and less. That also means that user-end heavy workloads have been scaling perfectly fine for a long time now. Kernel-heavy workloads, not so much, but it's getting much better now, finally. So SMP with the classic big lock, what does that mean? As soon as one CPU enters kernel land, no other can, so all other CPUs will wait for the first to finish. So that's mostly talking syscalls and interrupts. To overcome this, we need final locking, obviously. In some places you can get away without locking at all by using lock-free data structures, but this is not a universal path out of that bottleneck. It's not possible in too many places. Getting to finer-grained locking, we really don't believe in the way that other OSs have chosen with doing a line of train wreck releases that are unusable.
They don't believe in it anymore either.
That's right. They don't believe in it anymore either. And by now they admit that they did a train wreck release line. We've been working on this for ages and have not made much visible progress. Because whenever you fix the subsystem and you try to unlock it, you realize I can't because some dependency is not ready. So you start working on that dependency, then you want to unlock that, and then you figure out there's another dependency that is not ready. So you're working and working and working, and you're not getting anything back. However, at some point, when you got them all fixed, within basically no time whatsoever, you go, all fixed, unlock, 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 until you receive the gratification instantly. And in most or many corners of the kernel, we are reaching that point now. The speed in which SMP improves right now is fascinating to me. Just looking at the number of syscalls and the ones that run without big lock over time, I find kind of interesting. You see that there was basically no progress for a long time. Like for ages, we only had one unlocked syscall. It was getPID, which is not as irrelevant as it sounds because that's being called a lot. When you see, starting with 5.0, the number suddenly increasing, you see one release where we figured we had one unlocked that wasn't completely safe, so we had to revert that. We are not perfect. And you also see that the number is rising fast since 5.6. It doesn't seem to rise fast between 5.7 or 5.8, but there's been a couple of subsystems. Actually, most of them are to be unlocked or have been unlocked after 5.8. The priorities shifted a bit from syscalls to entire subsystems. I'm only looking at the standard syscalls here, not the unimplemented or obsolete ones. As I said, the first was get PID, which obviously isn't all that hard. In 5.0 we added the clock-related ones. We added set UID JIT, yield, and get thread IE. 5.5, well, this makes it sound much nicer than it was. Basically, we discovered a mistake. 5.6, unlock the UID in France, which is also kind of interesting, or helps quite a bit, because that also is being called a lot, foremost in libraries where you don't expect it. And the new get entropy syscall, which is the backend for, or one of the backends, part of the backend for the random number generation subsystem, is unlocked, so that helps, because we call into the random number generation subsystem a lot, which also improves the quality of the random numbers, because the calling pattern is unpredictable. And in 5.7, it's sig procmask and get dtable count, which are pretty frequent too. The Reaper is interesting. What's the Reaper doing? The Reaper basically just gets rid of exited processes. Sounds simple, turns out it isn't. It isn't at all. At some point, one of our Australian developers, DOG, observed that the Reaper is taking up to 20% of his CPU time on a web server. So, of course, it was clear that we wanted to attack that. We had it unlocked, then figured it's unsafe, then locked it again. But we're finally at the point where we can unlock, and just did, and I hope it stays unlocked this time. So that's going to help. mmap in OpenBSD is the backend for malloc, so it matters a lot. Of course, I'm talking about the anon case here, without file backend. At the hackathon earlier this year in Australia, we got to the point where we can unlock it, but it was close to release, so it was too dangerous, and we just unlocked it now. Again, I hope it stays unlocked, and then next release here being 5.9, because 5.8 is about to be released, but already done. I hope you'll see mmap and mmap unlocked there. The question I get a lot is about the network stack, SMP and the network stack, and SMP and PF. That's been one of the cases I mentioned earlier. You're working on something, then realize there's a dependency, and another dependency, and another dependency. There's been lots of progress, but it's been invisible, because, as I said, dependencies in the way. We didn't just go and try to unlock as fast as possible. Basically, whenever we touch a subsystem or a corner of the kernel that hasn't received loft in a long time, we are not just doing the minimum, we are spending more effort and time with that subsystem, and in many cases actually redesign it, because the world has changed over the last 20 years. In the network stack, that means rethinking the queuing points, because those are pretty critical. SMP for PF doesn't quite make sense before the underlying subsystems are unlocked. I mean, having PF run on 4 CPUs is nice. If your network stack is bound to 1, it's not going to help you, because the time you spend in PF on a typical box, even on a router forwarding or on a firewall, isn't all that high. Now we are mostly there, unlocking more and more, and yes, we are finally working in PF as well. The general pattern that you see a lot in OpenBSD, we are often pretty damn late to the party, but we believe in doing it right instead of doing it quickly, and I think it pays out in the long run. OpenBSD is very well known as the firewall OS, right? It's also good for processing medical data. And a lot more. Some of them are surprising. It's not just network-facing tasks. Of course, that's where an OS that focuses on security is very interesting, because I mean, you're connected to the big bad internet and don't know what's coming. But there's more. It's not just servers. Surprising to many, OpenBSD does make a fine desktop. We were the second Unix-like OS operating system that had DRI and kernel mode setting and all that kind of stuff that you want for modern X and fast graphical user interfaces. We do have the entire set of desktop applications you very likely, that you want, and very likely you will find all of them in packages and ports. And that includes KDE and GNOME and LibreOffice and Firefox and Chrome and whatever. I don't use a lot of those, so I'm not very competent in that area either. Is this public enough? Can I say names? No, okay. There is one company that provides OpenBSD desktops for, I think, thousands of machines, thousands of users.
That you can mention, but not the customer company.
Okay, so I can mention it's Mtier. So Mtier provides managed OpenBSD desktops, basically. And I think that's a critical point here, because let's be honest, the OpenBSD installer is not friendly to people being used to Windows. However, if you supply people with a ready-made OpenBSD desktop running GNOME or KDE, they won't see much of a difference to Linux. They won't even see much of a difference to what they are used to. It's not too big. And, well, do they even know they work on OpenBSD? Probably not.
Well, it's just GNOME 3 to them. So.
Exactly. All they see is GNOME. Do they even need to know what OS is underneath? They have a job to do, and the job is not fiddling with the OS. Another part that I find interesting, because it's so surprising, is actually the audio subsystem. That firewall operating system has a pretty damn fine audio subsystem with very, very low latency. Is there a joke that I didn't get? Well, I'll figure it out eventually. The audio subsystem has very, very low latency, which is very important to the audio guys. It's super flexible, and surprisingly to me, we do have support for all these gazillion of audio channel audio cards with their little tiny pre-processing thingies that I don't know much about. Hey, another area where I'm not competent in. There actually are live concerts, performances where OpenBSD serves as the MIDI synthesizer. Not even network connected, probably, so no firewall task there. Firewall the concert from the world? That doesn't make sense. So hardware support is another area where many people are whining, and this is actually something that all the free and open operating systems share. Hardware support, you have to carefully select your hardware. Well, reality check. How do I order servers for my company? I call our supplier and say 2 more. I don't specify anything more. Like, they roughly know what kinds of what amount of RAM and disks I want, and that's it. I don't tell them which network chip, I don't tell them which chipset. It doesn't matter. Whatever they ship me, it always works so far. And they don't test it beforehand, so it's not tailor-made, it's not an accident. So all in all, usually whatever I run into, it just works. Of course, if we're talking about super obscure hardware, that'll only run on Windows, but we're talking about hardware most of you have never seen or touched, including me. There's one notable exception, that's NVIDIA graphics, which we purposefully don't support too well. Why? Because it's undocumented, completely undocumented. Opposed to other operating systems, we don't believe in throwing a vendor-supplied binary blob into our kernel running with full privileges on the machine. Solution to that is easy. Just get proper hardware. Buy a machine that has ATI, nowadays AMD or Intel graphics, or just live with unaccelerated graphics, because then it works okay. End-user usability is something I briefly touched with the desktop usage already. Well, yes, we do not have that fancy graphical installer. Well, we actually like it that way. It takes you 10 minutes to install. Where are you? Brandon? There. It takes you 10 minutes to install a machine. It takes me 15, but that includes unpacking and racking the machine. So in most cases, you can just install by entering the hostname and the root password and press enter otherwise. I don't even do that anymore because our auto installer is now at the point where it's very usable in bigger scale.
Plus, you can install on a machine with something like 256 megabytes.
Yep.
It doesn't work with CentOS 7. The installer needs over 1 gigabyte of RAM or it won't even start.
Awesome.
Also 1 gigabyte. If you have 1 gigabyte, 1024 megabytes.
That's supposedly a server Linux, right?
There you go.
So on a server Linux distribution, you have more than a gigabyte of RAM to even run the installer. Awesome. I'm trying to remember how much RAM I have on my little OpenBSD box at home serving as a router. Is it 128? Yeah. The minimum these days is still 32 or 64. Did anybody test it recently? Probably not. 64 now? On AMD 64 or i386. On the older platforms, you'd get away with way less. HP 300 is maxed out at 12 megabytes. Okay, we deleted that platform. The VAX works fine on 20 megabytes. Yes, it does. I have one. It even is somewhat fast. It does make build in roughly 2 days. The most interesting architecture we had, it's been deleted a couple of years ago. I'm not saying which architecture it was. Some people might be able to guess if I reveal the one bit. The bootloader had 70 megabytes. Nobody?
UEFI?
Well, it was not UEFI, but so we are getting back to 70 megabyte bootloaders. No, that bootloader was called macOS. So I'm talking about Mac 68K. That platform was super, super interesting because they basically screwed up everything that could be screwed up. Every damn hardware architecture has all of them have one thing in common, and that's the order of interrupts. The highest priority interrupt, aside from NMIs and that kind of stuff, usually is the clock, like the ticks, not the real-time clock. On Mac 68K, they managed to put the clock interrupt somewhere in the middle, so disk had higher priority. Network had higher priority. So make build on the fastest Mac 68K ever made took 7 days, but the machine thought it was done after 5. So I got sidetracked. It's not only that we don't have that fancy graphical installer, we also don't have the fancy graphical system config tool. I suppose there is something in KDE or GNOME that configures bits and other bits, and I'm also pretty certain it doesn't work as well as on Linux, but, well, we like it that way because the goddamn command line is so much more efficient. Yes, the learning curve is steeper, but once you're over it, yes. The consistency and the good documentation, from my point of view, make it very, very, very user-friendly because you don't run into surprises. And this is something I value much more. So we are very user-friendly by not surprising you. Commercial support is something many people whine about. Well, reality check, it is available, including from me, from many, many, many sources. It usually, in practice, is much better than the vendor support for commercial OSs. Read the fine print. The fine print usually says we are going to help you because you pay for it unless we don't. Seriously, no kidding. Regress tests. Most of us, we don't write enough regress tests, and that kind of sucked because we might introduce breakage without noticing it. The most common pattern in finding breakage we introduced is actually using our systems, which we do. You don't see many OpenBSD developers here running around with laptops running macOS. We actually eat our own dog food. So we do find these, but it's not systematic, which is sad. So systematic and frequent regress testing would be so nice and so good. More automated too, but this is not the key point. It takes somebody to do it. And it doesn't take kernel programming, C skills, and assembler to do this. I suppose almost everybody in this room could do this. The issue with the regress test is not really a framework problem. What we have is kind of basic, but it's okay. It's good enough. NetBSD's ADF, which FreeBSD is using these days as well, is more advanced, and it might be a good idea to get this over. Last not least, because they already have a lot of tests written that apply to us in the very same way. However, that still doesn't solve the underlying problem. Regress tests have to be written. We do have a couple of developers that are very, very good in doing so. I'm foremost thinking about Alexander Bloom here, yes. Basically, whenever he commits to whatever part of the kernel or user land, it's followed by a second commit in regress. And that's the right thing to do it. Unfortunately, most developers, including me, don't do that. I don't have a solution to that. Any questions? I'm perfectly in my time frame because I thought you guys have questions.
What is your favorite pastime?
What is?
Your favorite pastime? If I look at the pictures, it's...
Oh, it's all pictures from my neighborhood. For some reason, the Hamburg government thinks we need a permit to have a fest on the streets, and we don't think so. No? No more questions? Well, I failed the slide. I tried to put Öl in there, but UTF-8 and Magic Point don't mix all that well, surprisingly given it's Japanese. Yes?
How is support for Intel graphics and all the new fancy stuff?
The new fancy Intel graphics, question whether they were supported? In current, not in 5.7. It was after 5.8, right?
Yeah.
What's the last supported in 5.8? That's I can't remember these code names. Broadwell?
Like X250, X1. Well, the ThinkPad models as a reference. Yeah. So whatever CPU.
So the X250 works in 5.8? Works in current.
Yeah.
So the X230 works in 5.7?
So 40 works in 5.8. But the newer ones work with current, but not with 5.8. The newest models.
You can see how much I deal with modern desktop machines.
Okay, the 240 works.
So 240 works, 250 only works in current.
On the chipsets, it's Broadwell that's supported since, I don't know, a couple of weeks?
Ah, so Broadwell is the new one.
Yeah.
Okay.
The latest one, Skylake,
Does anybody know about Skylake? I've never heard that term before. Not supported? Not even in current?
I think Haswell is needed, but it's now kind of like Skylake and Broadwell was released a couple of weeks ago. Yeah, there is no hardware yet.
Well, how can we support hardware that doesn't exist yet? Actually, that has happened a long time ago. This was just before AMD 64 came around. We had two machines where the processors identified themselves at AMD Athlon HX. This is something that never hit the market. They had the most awesome BIOSes that I've ever seen. You turned the machine on for about 5 seconds. It said, not for resale. And then you had the OpenBSD boot prompt. That's fucking awesome. They also ran at 1 gigahertz or so. Like, I think the first model that hit the market was at 2.5 or something. It was interesting to get them through customs. Yes?
I have a question regarding PF and threading.
What do I know about PF?
You mentioned that there is a lot of other subsystems that first needs to be fixed to support the processor machines. What subsystems would that be, especially on a machine that doesn't really
Okay, so the question basically is what subsystems below PF on a pure firewall have to be unlocked for SMP and PF to make sense. The most obvious one are the lower parts of the network stack. As said, the time you spend in PF for a forwarded packet, that's some 5 to 10% depending on your rule set, assuming relatively easy rule sets here. Route 2 or something like that is more complex, but normal rule sets you're spending 5 to 10% of your time in PF only. So if you unlock PF and it's twice as fast, well, congratulations, you gain 2%. The other one that's not all that obvious is all the memory management subsystems, foremost pool. If you have to grab big log every time you need to acquire memory, parallelizing PF is not going to cut it. Pool is SMP ready and unlocked now, so that's solved. The network stack's got much better, so we are now at the point where it starts to make sense. There's another bit I want to add here. The making it SMP ready is always received as going to improve performance a lot, and that's how should I put this politely? That's from people who don't understand the problem space very well. Especially in the network stack and especially with forwarding, we are dealing with so many shared resources. The prime example, of course, being the routing table. So every time you want to touch the routing table, you need to lock it. Congratulations, you are locking it massively parallel now. What did you gain? So a 2-core parallel PF on an unlocked PF, which isn't there yet, on a 2-core machine, I don't expect that to be any faster than a single-core machine. I expect a 4-core machine to be faster, yes. And given that the smallest machine you buy now has 4 or 6 cores, it's about time to do it. But as said, it doesn't scale. These kind of workloads don't scale as well as you think they do, because of all the shared resources. I'm sorry for you. But Route 2. I'm trying to kill this for a decade. No, it sucks. It's well, Route 2 at that level is a design mistake, and the implementation is a bit. No, actually, it got a lot better, but. So one bit, the PF on your pretty current FreeBSD is what, 5 or 6 years old? It's before the big redesign. PF itself, like PF isolated, since then is depending on your micro benchmark 3 to 4 times faster, but that's PF isolated, not the entire stack. So using that ancient PF version and then trying to add fine-grained locking, like what the hell? You're just guaranteed that we cannot share that code.
Yeah, I know.
So that's stupid. Sorry, it doesn't make sense. Also, the locking as it's being done there, I believe it's wrong. But since well, I'm not saying it doesn't have an effect. It certainly has. I mean, how many cores do you have on that machine?
24 on some just 8.
So 24 cores. Congratulations, you are faster than a single core machine. It would be shocking if you aren't.
Yes. Okay, so you tell me I should check your...
You're throwing hardware at the problem.
Huh?
You're throwing hardware at the problem. I believe in doing it right.
Okay, I will check. Thank you.
You are not hacking in that area, are you?
What do you mean hacking?
Like programming, coding.
Yes, I did some bug fixes that was
Okay.
EuroBSD, not EuroBSD, sorry.
So the point I was trying to make, then you are not the right example here, the point I was trying to make, I also understand the sysadmin perspective. If you are not coding in the area yourself, you have no other option. So I'm not trying to blame anybody here.
Just root to the site, be it different. But I understand you say normal routing table, normal server, of course. Then you're right. In my case,
Well, of course it gives you improvement on a 20-core machine, 24-core machine. As said, it would be shocking if not. But yeah, we're getting there. I think I used the term before. OpenBSD is often late to the party, but then doing it right. Well, from my perfectly neutral, unbiased point of view, of course. Is that a question? Yeah. Not at all.
Unless you get a 10 gig DDoS. But you're not going to run 10 gig.
I've been dealing with 100 gigabit DDoS for most of this year. Well, how should I put this? The firewalls were not the problem. No, the upstream routers were a problem. These the cost of a house routers. But of course, I mean, it's kind of clear we are not going to cut 100 gigabit on a commodity AMD64 machine with OpenBSD. Not with FreeBSD either. Of course, we are talking 64 byte packets. Like, no way. It was UDP to port 80. OpenBSD is host or guest?
As a group, you said that you had some customer who was asking you support for OpenBSD somewhere in virtualized environment. Yeah?
The weather is nice today, isn't it?
Do we have any ideas, plans to support some hypervisors as guest, OpenBSD as guest, and any plans?
So OpenBSD as guest and hypervisors is perfectly fine. The support for that actually makes quite a difference for virtual I/O for both network and disks is there, works fine. Never seen any issues. It's fast. I like it. OpenBSD as a host is not there yet, as Brandon mentioned. It is right. You can have OpenBSD as your hypervisor, you just have to run on Sun 4V, which, reality check, it doesn't cut it. The machines are too slow to begin with and too expensive as well. Like for the cost of a small car, you're getting a machine that's slower than anything you can buy in the PC world today. So. But yeah, OpenBSD hypervisor is coming. I'm not working on that, so I'm not making any predictions. It'll be there the next release. It's just a question of the next release after which next release. I'm using OpenBSD as guest a lot. Isn't the weather nice today? It's Linux KVM.
I use it on Xen server. So.
On?
Xen server.
On Zen works too. Beehive works fine. I don't notice any difference to other operating systems. Like we're not shockingly fast there, as in faster as anybody else, and as in noticeable. I didn't really measure. We're not slower. It just works. And actually, I hate saying that on Linux KVM. I'm not seeing much of a performance loss from OpenBSD on bare metal versus inside, which is kind of impressive. So they eventually got one bit right at least. Okay, thank you. And I hope we'll have some öl together tonight. Thank you.
Ich habe auch nur einen kleinen kleinen QEMO-Fix und dann läuft auf unseren Server. Für die Pre-Tests geht aber.
Thank you. Is this, okay, I can sometimes hear an echo, sometimes I can't. So I'm going to talk about cryptography in OpenBSD, another overview. And so the motivation for this talk is actually, there's a paper presented at Usenix conference in June 1999 called Cryptography in OpenBSD, an Overview. And as the title implies, this was a survey paper that looked at all of the many places that OpenBSD had incorporated cryptography or encryption or other cryptographic operations. And it's a pretty good paper to read. And the only problem is OpenBSD is now 20 years old. So this paper was written only 20% of the way through the OpenBSD project's history. So the question is, how relevant is that paper today? And it's actually fairly relevant still, but with quite a few caveats and footnotes and disclaimers and little asterisks and so forth. So through the years, various OpenBSD developers have given presentations that, hey, I did this or I did that, and we've changed this and we've changed that. But there hasn't been a complete update to this paper, and so it can actually be kind of hard to tell what parts are out of date and what parts are still relevant, because you have to go through 16 more years of presentations, and a lot of them are actually not so much in paper format as just kind of random magic point slides. So if you don't go to the right slide, you'll never know that something changed. So I'm here today to collect all of the, just kind of walk back through this paper from 16 years ago and look at what's changed and kind of officially provide an answer as to whether yes or no, that's still true. So before we jump into the paper, we should kind of review what is cryptography. And as my friend CryptoCat here says, it's what keeps secrets safe. And so cryptography is the science and in some ways kind of an art that allows that to happen. And so for many people this means encryption and ciphers, but it also means things like random number generators and other principles that we can use to protect our data. So let's go back to 1999. For those of you who were installing OpenBSD in 1999 or so, you'll remember this is only a couple years after PGP was released. Kind of crypto wars with the U.S. government are in full swing. There were crazy export controls, so if you wanted to ship something out from the U.S. where most software was being developed to another part of the world, you were limited to 40-bit DES keys. There was a patent on RSA, which meant that you couldn't provide that in commercial products. You had to use DSA and Diffie-Hellman. And so cryptographic software was available, but like I said, it was hard to get. You either had to print it on a book and smuggle it out of the country, or something that was not code, or you could re-implement it. So actually, right here in Stockholm, KTH was re-implementing a lot of things as well, and to provide alternative implementations and so forth. So what happened was, the background here is that OpenBSD, coming from Canada, was not subject to these export controls. And so it was one of the first operating systems that could integrate cryptography deep into the operating system core, where other operating systems had to leave the crypto kind of on the side so that they could remove it, such that they could put it on like a CD-ROM that they could then mail outside the country. And of course, the best symmetric algorithm was DES, maybe 3 times, Blowfish was around, but Blowfish was not officially blessed as a standard, and so for many applications you were stuck with DES. So the paper outline, was broken up into 3 sections. There was network security, then there was randomness, and then there is storage security. And so I'm going to follow the same outline. So we're going to cover SSL, and then we're going to cover some IPsec, then random number generators, dev random, arc4 random, and then finally storage security, which is like file systems and also bcrypt. And okay, network security, we got SSL, IPsec, we also have Kerberos, SKey, SSH. One thing that I noticed through the paper is the ciphers it talks about throughout the paper, kind of not covered in any specific section, but they're indirectly referenced. And so there's a lot of talk about how RSA was patented and we couldn't use it, and so you had to install this shared library. After you installed, you could do a tar unzip of like a new library that would override a function that only had stub functions in it. And so OpenBSD, that situation been resolved quite a long time ago, thankfully, and we've also added like SHA-2, AES, and moving forward, some of the newer things, AES, GCM, and even like Cha-Cha 20 with the Poly 1305 Mac. And so these are cryptographic primitives where it's authenticated encryption. This wasn't really, so we now know that this is a substantial improvement over the typical encryption that was done in the 90s. And also RSA itself is deprecated, I think in some ways, to elliptic curves, which provide you with much smaller key sizes for equivalent security. And so you don't have this like 4K key that you can't possibly enter by hand. And I think one thing that I should mention, I thought it was funny because the paper specifically mentioned, oh hey, we added skipjack, which in order to get a government support, but skipjack was removed some years ago, and I don't think you actually need to support skipjack for the U.S. government to buy your product anymore. I think actually the U.S. government will not buy your product if it uses skipjack at this point. SSL. So OpenBSD imported SSL EAY, which then turned into OpenSSL. And so we shipped libSSL in 1999. However, since then, SSL v2 and v3 support has been removed, along with some other code. And this isn't really the libSSL talk entirely, but it's kind of funny to read some of the forward-looking statements, because there was a big plan to incorporate SSL into everything from FTP to Telnet. OpenBSD doesn't even ship a Telnet client or daemon anymore, and so there's no way to SSL it. Actually, FTP did grow SSL support. The FTP client in OpenBSD speaks HTTPS, but it does not speak FTPS, which I don't, and so we've also, I think more towards the future now, we're focusing our efforts on libTLS. Bob Beck actually gave a pretty good presentation about this just 2 weeks ago in Croatia, so I'll refer you to that for what's going on there. In the world of IPsec, Futurus is gone. Futurus used to be the easy way, apparently, of setting up IPsec. I don't know, because so the 1999 paper, to summarize about 2 pages of the paper, look at all of these moving parts we have. It was very complicated to set up. The paper acknowledges this, and so really not much has changed on that front. ISA KMPD is still there. It still does the IKE v1 protocol, but now with RSA. But I think the future is the IKE-D, which now speaks the IKE v2 protocol. And you can now, as of iOS 9, even connect your iPhone to an OpenBSD server, as long as you have a patch from yesterday. But so I think, but it's getting pretty simple. Like the config file for that is now 6 lines long. You type a password there, you type a password on your iPhone, and you're pretty much set. But don't worry, there is ongoing work to make the RFCs much more complicated. So Ike v2 will be hard to use eventually. And I guess one other thing I should mention is that there was a lot of this forward talk about using IPsec opportunistically, where any random application would actually be able to request an IPsec channel, and then it would be negotiated on the fly with the endpoint it was connecting to. So this is kind of like set sock opt IPsec, and then you get IPsec encryption to wherever you're trying to go. That did not happen. OpenBSD does not support DNSSEC yet either. 16 years later, people are still telling us about the wonders of DNSSEC.
Of course we do.
Well, we don't use it.
Unbound first.
Okay, yes. Okay, so OpenBSD has Unbound, so yes, you can use DNSSEC, but you cannot integrate it with your IPsec flows. Can you?
Why would you?
Well, it said you could. That was the next step.
Maybe I'm not smart enough.
No, it's true, nobody uses DNSSEC, and then he...
A lot.
Okay. Talk to Henning if you want to know about DNSSEC. So Kerberos then supported, thanks to the KTH developed libraries, we supported Kerberos 4.
The source yesterday.
And yes, I was in the building apparently where they wrote this. And then it was upgraded to support Kerberos 5. And then it was all deleted. At one point, sudo and xlock and all these things were Kerberized. Now none of them are. The problem there was the code base just kept growing larger and larger, and so every time we imported a new version of Kerberos, you had to add a new library to link SSHD and all these other things to, and eventually the link line for SSHD didn't fit in 80 columns, and Theo kind of lost it, and so he said no more Kerberos. So SKey is a one-time password system. It's kind of predates some of the one-time password type systems in use today, but it's still there. It still works. You can still use it. No real updates necessary. So SSH in 1999, the quote was, "There is no free implementation of SSH available." The good news is there is today a free implementation of SSH, and you can use it. The story there is, for those of you who don't know, the very early versions of SSH were released under a free license, but then before it really caught on, Tattoo it changed the license to be less free, and it also incorporated a number of patented algorithms, and so it was actually difficult to use this in a free software project. So actually just shortly after June, in September of 1999 is when the initial import of SSH into OpenBSD took place, and so obviously a lot of work has gone into OpenSSH, and this subsumed a lot of the proposed talk of encrypting Telnet and so forth. I think all of that effort went into SSH, and so from the early days of only supporting protocol version 1, protocol version 2 was added. There's also a much larger cipher suite supported now, including a number of kind of not RFC track things like Cha-Cha-20. And then there's also, so now actually what we're doing is we are removing features from SSH. So protocol v1 has been disabled, and some of the older ciphers are getting deleted. So you can no longer connect to a SSH server that only supports MD5 max and so forth. Yeah. Very sad. So randomness. Quick review of dev random, arc4 random, and where randomness is used, and some of the applications. Dev random, in 1999, there were I believe 4 different device nodes in /dev. There was A random and P random and U random and S random. And each one of them gave you something slightly different based on how it was, trying to estimate the entropy, and you got to like pick your quality of whether this was going to be a really good key or a really, really good key. It was kind of ridiculous. So the underlying technology is kind of still the same. We still collect entropy from, network interrupts or keyboard presses or whatever, so whatever kind of things that happen, get stored into this entropy pool. That is then hashed with SHA-512 now instead of MD5 to create a key, which is then used to seed a CHA-20 stream, and which this used to be RC4, now it's CHA-20, but all of the device nodes in /dev now return the exact same thing, which is a never-ending, never-blocking pile of CHA-20 stream. And so there's this nonsensical distinction between good entropy and bad entropy has been completely removed. And even better than /dev nodes, there's a new system call getEntropy was added, and so this allows programs that are even in like a chroot jail to get entropy without having the sysadmin to make a dev node for them. It works even if you are at your file descriptor limit and you can't ever forget to close the file and so forth. So random bits are available to any process at any time, always. So the primary interface in libc for random number generated for random numbers remains arc4random. That is the name of the function, not the implementation. And so we've actually been much more aggressive about using it in userland. So more and more calls to old rand or random or whatever were replaced with arc4random. In fact, random itself is actually now arc4random unless you call this magic please give me deterministic random numbers function first. And so it used to be based on the RC4 cipher, which was one of the at the time the best, fastest stream cipher available. This is now CHA-20, which is substantially more secure. And a lot of the old API functions that are no longer necessary have been removed. So it's no longer necessary for you to manually stir or seed the generator. And in fact, the functions to do so are no longer there. So you can't even try. It just works. And also the code was refactored quite a bit to make it easier to port to other operating systems. So we are proposing not just that this interface exists, but also the code is now available so anybody can use it on just about any operating system. So there's an interesting side note in the paper about non-repeating random numbers. And these come up in a number of places. For instance, your initial sequence numbers for TCP, you do not want to be predictable, but you don't want them to repeat because the way the BSD kernel detects old connections in the closed wait state is to just kind of keep those around. And so if you accidentally reuse a sequence number that's in the window of a previous connection, all those packets get dropped. So in 1999, basically the state of the art was incrementing your ISN by a random amount. This actually is insecure because a whole bunch of random numbers, a whole bunch of random increments over time will average out to the mean of the increment, and so you can attack it. And so then OpenBSD switched to truly random ISNs. But then we had the problem where you would accidentally repeat ISNs. And so now we finally circle all the way back to the RFC 1948 technique where you hash the source IP and some other things and a secret key, and then that gives you a base that is unique for each person you're talking to, and then you can increment that by a fixed amount. And so It's unpredictable per source target, but it also gives everybody a monotonically increasing sequence. And then there's also a lot of 16-bit IDs, which you can, doesn't really provide a lot of security, but so these are using like IP IDs, and also in DNS. The ID for a DNS packet is a 16-bit number. In 1999, there was a linear congruential generator, LCG, that was used, and this was seeded by arc4random, and then an LCG will give you a deterministic sequence from a particular seed, and so you'd have to reseed it periodically to get new sequences. And it did this neat trick where it just flipped the high bit back and forth every once in a while, so that it would generate a bunch of low numbers and a bunch of high numbers and a bunch of low numbers, and that prevented it from repeating. In userland, we now use a improved version of that LCG, which protects against some prediction attacks where you could kind of determine the seed after looking at enough outputs. That's more difficult to do now. And in the kernel, it actually uses a shuffled array. So you take 32,000 numbers, you stick them in an array of 32,000 elements, and you randomly shuffle it, and then you just kind of peel them out as you need to. We use that in the kernel because there's only one IP ID pool, but in userland, the cost of setting up that array to make a DNS request is kind of high, and so because most userland applications might only make 1 or 2 DNS lookups, and so you don't want to create this giant array every time. All right, secure storage. Long ago, a number of utilities in base supported DES encryption kind of out of the box. These included VI and good old ED, and a program called BDES, which would encrypt things. And so if you had a secret file, you could edit it with ED, and it would you could type in your password, which could not be more than 8 letters, because those 8 letters were going to literally be the DES key, with the high bit stripped, I think. And so, I mean, this was pretty bad. This actually, I think, was carried forth in OpenBSD for far longer than it should have, and I deleted this support about 2 years ago because it was kind of embarrassing, and also, it's like somebody might actually try to use this, and then you're going to have these files which, like a PS3 can decrypt. So the sad thing is there are no good tools in base at this time for file encryption. I do not consider the OpenSSL command line tool a good file system encryption utility. Kind of fading off there. There was also apparently I actually have no idea what this thing was, but Core SDI invented a secure syslog, which encrypted packets in some way. I don't know what it did. They were going to import it. They didn't. But more recently, TLS support was added to syslogd. So you can set up your OpenBSD machine to syslog over a secure channel and know that your logs aren't being injected midstream. So bcrypt was introduced actually there was an entire talk in 1999 introducing bcrypt, the password hashing algorithm. There's not a lot to say that's new. I think it's held up pretty well, for a cryptographic primitive introduced in 99. And this is also, I think, found quite a bit of success outside of OpenBSD. There are probably more bcrypt, Ruby on Rails sites than there are OpenBSD systems, running on Linux. Though, of course, Linux doesn't have bcrypt in libc, because why would you want to use it for a system account? We've increased the default round count slightly, and more recently added auto-tuning, so depending on the speed of your CPU, it'll now just pick a value that's takes a while on your CPU, but not too long. They should make it a little easier. So if you have like a super screaming machine, you can, you don't have to worry about changing the knob. Disk encryption. So CFS is very dead. CFS was a kind of hacked up, well, I think it was a cool idea at the time, but it was basically an NFS proxy, which would, you could mount it and then it would loop back mount, export a local file system, and all the files would be encrypted as they went through this NFS mount. But the crypto's kind of old on it, and it supports, I think, only an aging version of NFS, and I don't know if I don't trust NFS that much either. So VND grew Blowfish encryption a little while ago. It's okay, you can still use it, but I think the best option today is SoftRaid. Stefan talked about SoftRaid boot a little bit, but so SoftRaid crypto uses AES XTX mode, which is a block mode that's specially designed for disk encryption. You can encrypt the whole disk, including the boot partition, so you don't even have to worry about maintaining like some files in /boot. The whole thing is encrypted top to bottom. It's very transparent. You can even hibernate to it, and so you can, if you are worried about having the contents of your RAM secure when you hibernate your computer, they'll be encrypted, and so then when you reboot, it won't be able to decrypt the hibernate image until you type in your password. So some new additions that we've added that weren't on the horizon in 1999. Signify, I've talked about this before, but I would be remiss if I didn't at least mention it. It's there, we use it, it signs, it verifies. So I think actually another cool thing that we've done is SIP hash. So SIP hash is a fast keyed hash function, or sometimes referred to as a pseudo-random function. It takes an input and generates a 64-bit hash. So this is much shorter than, say, MD5 or SHA-512, which of course generates a 512-byte hash, but it's much faster. And it was originally designed to help protect against some things like algorithmic attacks against hash tables, where people figure out what your hash function is for your hash table because you're using something silly like XOR all the bytes together, and then they generate a whole bunch of inputs which collide, and then your hash table has these giant long bucket chains, and then it becomes a linear traversal instead of a hash table lookup. But using SHA-512 in those cases is kind of overkill, and it significantly slows you down if you have to process a lot of inputs. And so, like in OpenBSD, if you're using trunk load balancing, you want to hash the packet headers so that all of the packets for the same stream go out the same trunk port, but you don't want to be doing a SHA-512 hash on every packet. So we added SIP hash a year or two ago. Have been using it in a lot of places. Pretty much every place that somebody had rolled their own hash function, and there were a lot of them, and a lot of them were very bad, have pretty much all been replaced with SIP hash. And it's a pretty cool interface. And I guess tying this all together, I want to say a few things about ping. This is mostly work done by David Gwynn, I think. But so you want to have so when you send a ping packet to somebody, you want to include a timestamp in it, because then when you get the echo back, you can tell how long ago it was that you sent this packet. But you don't want people to know what your system host time is, because that's a secret. So we add a random offset to the timestamp, and so it'll say this. The timestamp in the ping packet will say it's like the year 2070, and then when it comes back, you subtract off a couple years, and then that tells you which one it was. But you also don't want people to send you back fake packets with fake timestamps. And so we actually use SIP hash to generate a MAC for the ping packet payload, because SIP hash is a lightweight thing. It doesn't require a lot of, this is kind of a silly application, so it doesn't require a lot of security, but it's kind of like, why not? We can just stick all this stuff in here and send, so now OpenBSD has these unforgeable ping packets. So I think, we're still kind of moving forward and trying to, introduce crypto in kind of new places and doing things with it that people haven't really thought about. Yep, that's the end. So any questions? Yes? Oh yes, okay. I've heard of this. Yes? Oh yes, Colin suggested that I use a program called scrypt to encrypt my files. And actually, I do use it for some things, so thank you. Yes? Yes? So yeah, yes, you can use SIP hash as a checksum. It's kind of just like a. So the question is, can you use SIP hash as a checksum? Yes, it's kind of like a heavyweight COC. I mean, it works a little bit differently in principle, but if you were using a COC, the only issue with SIP hash is it requires a key, a 64-bit key. And so that way it's unique. So you kind of, on the server side, like keep a unique key and then you hash inputs. I'm going to post a link to the SIP hash website. It there's a pretty good paper on SIP hash which tells you all the things you can do with it. Oh, that was half an hour. Oh, yes. Okay. Thank you, Renard. So,
We have the telnet client still.
oh, we do have the telnet client.
The daemon is gone.
Oh, okay.
The daemon, but not the client.
Why is this
It's okay that it's still there.
okay, yeah, so one minor correction, I did lie. We do still have a telnet client, but it doesn't support TLS. But we do have a netcat that supports TLS. So if you need to connect to something and you're tired of using OpenSSL S client, you can use netclat dash something T or S, or I think. Yes, and serve. So if you need to kind of whip up a quick TLS server, you can do that with netcat now. No, you have to, it is not a full man in the middle, attack kit yet, but if you're looking for that though, RealID can do that. So, yeah, it's just kind of a quick hack, but, and so I think, actually to give you a little more background on that, the netcat was done to demonstrate the new libTLS API. So we're trying to add that and use that in more of our userland programs. And so you can kind of tell it used to use OpenSSL, and then like the diff to convert FTP from OpenSSL to libTLS deleted about 200 lines and added 12 or something. So.
Could you explain again the aspects of software crypto combined with a zero disk or a random disk content? Because I can't really explain it, and this question came up in my talk, and I think you can explain it much better than me.
Okay, so there's a question about software and a zero disk.
Yeah, you zero the disk, and then you start using it, and then it shrinks the blocks, and you see zeros in the parts that haven't been used. There was some attack possible because of this. It was raised on the mailing list sometime. And you suggested to just randomize the whole disk before putting software crypto on it.
Oh, yes. Okay. I guess this kind of odd topic. So there is a issue with soft-read crypto, or I think actually any full disk encryption algorithm, where if you zero the disk first, and then you create an encrypted partition over top, and then you write data to the disk, the data that you have written is going to appear as not zeros on the disk, but all of the places that you have never written to the disk are still going to read as zeros on the underlying storage. And so I think the solution is you either you pipe dev random over the disk before you create the encrypted disk, or after you create the encrypted disk, you fill it with dev zero or dev random on the inside, so that you erase any tracks of what blocks have been written and what blocks have not been written.
What's the danger in not deleting these tracks?
Somebody will be able to know how much data you have.
Oh no!
Mostly, yeah. I don't, you know, yeah.
Can't this be an issue with SSD also, where you are going to stress out the file system much earlier?
I don't think one pass over an SSD is going to hurt it. So,
Pass is minus one.
yeah. Yeah, Colin.
So this is a specific case of what's more generally referred to as the evil maid attack. The idea is that you're staying in a hotel, and when you go off to dinner, the maid comes in and makes a copy of your hard drive, and then she can compare the hard drive as it was on different days when you went off to dinner on different days. If you start with everything zeroed, then she knows when she reads the first time which blocks have been modified, because they're the ones that are zeros. But if you just write it all with random numbers, you still have the same problem if the evil maid can read your disk twice, because she can still see what has changed between those 2 days.
Yes. So to summarize Colin's explanation there, you do not want people to be reading your encrypted disk, even if it is encrypted. And I think actually, but this is actually, I think I should actually, you could give a whole talk on the weaknesses in disk encryption and why I think people put actually too much faith in disk encryption, because people think it's going to block attacks that it's not going to block. And so there are various ways. I think disk encryption is really good for one use case, which is I left my laptop bag in the taxi, and I'm never getting that drive back, and I don't want anyone to read the contents. I think if you lose your laptop and it comes back in the mail 48 hours later, you should probably not trust it, and no disk encryption is really going to save you in that case. I think if you lose physical control over your device, disk encryption is not going to be the technology that keeps you safe.
There's a second case when you have warranty on your hard drives, and you want to get it back, but you have to send the original one back to the vendor.
Oh.
The drive is broken.
Yeah. Yes?
Do we have some benchmarks publicly available for IPsec in OpenBSD current? Because I ran this problem a couple of years ago, and was GCM, switching to GCM helped a lot, but what's now? What's the real numbers, if you know?
I have, question is if there are benchmarks for IPsec. I have no idea. I have like a 4 megabit cable line at home, and I don't even use IPsec. So I'm not the person that pushes OpenBSD performance-wise. But I think it's been getting faster, and the AES instruction speed up is definitely if you can use AES and AES GCM, that's definitely the fastest now.
How many megabit are you targeting?
Actually, we have over 1 billion, 700 megs, over IPsec.
Because
But for short distance.
I have long distance, and it's like 80 megabits, and I barely notice any CPU usage with AES 256 PCI.
IPsec and can't push more than 2 gigabits, I think. There's some limit they couldn't figure out. I'm not sure if this
It is, I don't know. I've never tried to push 2 gigabits of IPsec.
was this on OpenBSD or previously? Okay.
Ah, not my problem. All right, any further questions? All right.
Choosing that crypto protocols are being added or removed. Obviously, but on
Okay, yes. So what is the selection criteria for new cryptography? Or removal, yes. What is the sunset procedure? I think it's just kind of somebody has an opinion, brings it up on the mailing list and says, I think we should add this, we should remove this, and here's people using it. I think in the case of, say, like Cha-Cha 20 and the PolyMac that was proposed by Adam Langley at Google, who works on the Chromium team, and so I think Google kind of demonstrated, that it works at scale and it's faster than AES in software, and so that's why they are using it, and it's been pretty thoroughly reviewed. And so I think we don't want to import every new crypto algorithm, but if somebody out there is using it and we could interoperate with it, it would be a win to add some new things. And deleting the old stuff is just kind of how long has a successor been available? So in the case of like MD5, SHA-1 has been available for 20 years, and SHA-2 has been available for, I'm not sure when that came out, but around 2001, I think. So, there have been better replacements for a lot of these algorithms for more than 10 years, and SSH has supported SHA-2 for more than 10 years, and so there is no reason why you shouldn't be able to connect two systems running SSH using at least SHA-2 as a minimum. But then there was PuTTY, which only supported SHA-1 until a version that was released last year. So, so sometimes we delete something and then it turns out that people can't log in or can't connect to certain systems, and we have to carefully add back some things. But, I think there's kind of ongoing pressure to clear out the bottom line. Yes?
For IPsec, you mentioned with IT version 2, it will probably get more complicated.
Yes.
I guess we all know IPsec is. What do you think is the best alternative to IPsec? Using
So it depends on what you're using IPsec for. I use SSH tunnels for point-to-point links, and I don't use the SSH VPN functionality. I just kind of, open a whole bunch of ports on localhost and then they show up somewhere else. And I mean, that works for me. But I think IPsec has the advantage of being a standard. And so, like I said, I can't, my phone will run IPsec, but it's not going to run random other things that I could conceivably run on OpenBSD. So I don't want to go into OpenVPN. I mean, you could run OpenVPN too, but.
gateway soft ether, because that speaks IPsec, OpenVPN, and all in one daemon. Sure. Which one, sir? Soft ether. Okay.
Yes.
Did you have any kind of backstory or insight into this funny SHA-0 thing?
Yeah. So once upon a time, there was a SHA-0, which was a proposed secure hash function or secure hash algorithm before SHA-1 was standardized. And I think immediately after publication, they discovered that it was flawed, and so they retracted it. But it was nevertheless added to OpenSSL and survived in OpenSSL for 20 years. Although I don't think anything ever actually used it. It would be hard to use this even accidentally. But yeah, the code was there. Oh. Oh yes, and yes, and John the Ripper, there was a patch to add support for passwords hashed with SHA-0. Although as far as I know, no product ever actually hashed a password with SHA-0, but you could crack them anyway. All right. All right, do I get to go? No, anyone else? All right. Thank you.
Sounds like the sandbag.
How's that? Can you hear me? You want this to use to?
Yeah.
Okay. You want to just go or?
Yeah.
All right. So George couldn't be here. He's diving in Costa Rica. So he said he'd rather be here, but he has a relationship to maintain. So Made to Measure is a talk that George and I have done all year in different guises. We keep updating the information. So, benchmarking, right? There's lies, damn lies, and benchmarks. Benchmarking is hard, and it's hard for a couple reasons. First, you have to decide what it is you're going to measure, right? And then you have to know what that means, right? And how do we measure it? How do we get an interesting result? How do we get something that we can actually talk about and reason about and just, make changes to the system and decide we've made an improvement? How do we verify our measurements? How do we know that we actually are looking at what we think we're looking at? Is the measurement meaningful? This is sort of my favorite thing is, can we repeat the measurement? Can we duplicate our own results? And then also interesting, and this is sort of where, benchmarking of network stuff gets interesting is, can others repeat our results? And benchmarking the network industry is typically involved these really expensive $100,000 plus boxes you plug in, and you get some numbers out of them, but we're an open source project. We don't have one of those boxes. Right? And then like I said, is the measurement relevant? Does it mean anything? Because I can generate almost any number if I want to, right? And then from there you have to go on and sort of like, okay, what are we going to use to actually generate this workload? And like I said, most of us can't afford one of these breaking point boxes or these tipping point boxes, or Ixias, that kind of thing. All this stuff is really expensive. And then you sort of enter this next phase of the problem, and sometimes the testing you do affects the number you get, right? You probe the system. The probe effect is that during testing, you've actually changed the result. And this is especially true when you're doing things like benchmarking VM systems and that kind of thing. Benchmarks are harder because networks are asynchronous. You have things happening over here and things happening over here, and there's this great quote from years ago about networking is the Vietnam of computing because something can pop up behind you and cap your ass, right? And then, networks are also best effort. If you built a file system that dropped data, would anybody use it? Right? I mean, if you kernel data on the file system, no one would trust you ever again. If your disk kernels your data, that disk is bad and we will never use that vendor again. Right. Well, yeah. Networking, we drop packets all the time. It's like, hey, you gave me a packet. Sorry, I couldn't do anything with it. Hey, you gave me another packet. I got this one done for you. Networks drop packets all the time. And so, there's sort of this, what does that benchmark mean if we're constantly dropping packets? How much does that happen in production? Again, the sort of, complete lack of open source tools. When we started this effort, we went out and looked. It was like nobody came up with anything. We looked on GitHub. There was nothing really there. I mean, there's iPerf, but we use iPerf. There's a couple other things, but there wasn't really a good test suite to be able to run reproducible results. And then there's a whole sort of, since you have more than one system, you have to orchestrate across them. If you're going to run this thing without somebody actually typing all the commands all the time or designing one little shell script, you have to orchestrate, potentially 4 or 5 different boxes. This is the lab set up at Centex. The FreeBSD Foundation paid for this lab. It's got lots of, cool stuff in it. All the machines at Centex are named after animals. It's not a decision I would have taken, but I didn't set it up. One of the machines is named orangutan. Anybody know how to spell orangutan off the top of their head? Right? But, in general, and there's more machines than this, but you've got, for network testing, there's a control network that's, 1 gig Ethernet, no big deal. And then there's a, this side of the network, the fast side, the 10 gig side, and that's done with a Arista switch. They're pretty nice. George got one donated. And then there's, some machines that generate traffic and some machines that receive traffic, and typically there's this thing in the middle. And a lot we're going to talk about, when we started doing this back in February, March, we started talking about packet filtering, specifically PF, and today we're going to talk about forwarding and IPsec. So the hardware used, the sort of source and sync or dual socket 10 core, fairly nice Xeon machines. Are not completely up to date, but they're sort of one very slight generation back. The device under test, we always stuck with a single socket, and there's reasons for this. Dual socket is great for virtualization, but if your PCI NICs are against the wrong socket, you're always going across QPI with the traffic. And that induces latency, introduces actually a bandwidth throttling constraint. So there's a lot of reasons why, we cheat and use single sockets for the device under test. The NICs used in Centex are all Chelsea dual port NICs. They work great for a lot of things. And then, like I already said something about the switch, the Arista switch was sort of top of the line, right? The Netgate lab, I work for Netgate. It's very similar. We have a few different things. We use a different switch, although we're moving to a Seacliff Trail design, which is the same switch ASIC as what's on the Arista. And, my real dream there is to make FreeBSD run on it, because they run Linux now. We tend to use a lot of Intel dual ports, although we have some Chelsea as well. And slightly faster, although still single socket machines. Here's a sort of rough diagram that you can't see, but these are all the machines that we can use in various configurations for either device under test or source and sync, or create 4 and 5 host wide boxes with VLANs, or wide paths with VLANs. So we can simulate roughly almost any setup you want. This is for the admin interfaces, and this is for the 1 gig stuff, because some of the stuff we sell is 1 gig only. So modern hardware, the world's not a VAX anymore. I really enjoyed Paul's talk this morning, because when Paul was the guy doing the internet gateway at DEC World, I was the guy doing the internet gateway at Sun. I'm actually a little bit older than he is. But, back in the day, VAX, the VUP, he kept saying VUP this morning. Does anybody know what VUP means? VAX unit of performance. For a while, everything was measured in terms of how fast you were against the VAX, because the VAX was like an electron volt. It never changed, right? And so VUP was sort of this benchmarking number that compared your performance to what a VAX 11780 was, even though DEC didn't sell them anymore. Well, network, hardware is a lot different now than a VAX. And 10 gig is nearly 15 million packets per second, and that's a lot. 15 million packets per second means you get about 67.5 nanoseconds per packet, or on a 3 gigahertz machine, about 200 instructions to deal with that packet. So take the interrupt, do what you need to do, get it forwarded off into the queue, and get out of the way. 200 instructions is not a lot, right? Most of you write functions, if you write C, that are over 200 instructions long. And then you have all the effects from multi-core. You have, one or more sockets with one or more cores on them. Some people turn on hyper-threading, which is useful in some situations and very not useful in others. And then this whole sort of lining it up, FreeBSD is not NUMA aware. You can get some information out, but then you basically have to go sort of hand line it up back in the old mainframe. Same thing as old mainframe days where, my NIC is against the core where I'm actually going to run the instructions to do the forwarding. Because again, if you do this sort of cross QPI thing, you lose every time. It just will not run at speed. So we wrote this thing called Conductor. Set of Python libraries. It's basically an orchestration framework for a couple different tools that are already out there. You have one conductor or one master, and one or more players, sort of the devices that make up the test. And it's got 4 phases. It's a fairly simple, straightforward kind of thing. Startup phase, you load drivers, clear out state if you need to, potentially reboot the machine so you have a fresh start every time, set up ART tables so you're not waiting on that to happen. Run, obviously execute the test. Collect as you go out and actually get the log data, and then there's a reset phase if you want to actually get back to a known state for the next set of tests. The config is fairly simple. Unfortunately, it's got something a lot like line numbers in it because it was easy to code that way. We're actually probably replacing this completely. But you can say do one trial is not really statistically significant. I mean, what's one, right? Who knows what it's going to change? But so normally trials is a lot higher. This is just an example. So trials be 10. So we'll do things 10 times in a row and collect a set of statistics off that. Sort of client 1 is a host name, if you will, and it runs this config file. There's 3 different config files here, but you can have a whole suite of different config files for a conductor, so you can run a whole set of benchmarks repeatedly. Player config, sort of a bunch of information, IP addresses, the port. George went out and got a port. He actually got 2 because he wanted to know how hard the process was. And if you know anything about George, he's also, he writes for the IEEE magazine. And he occasionally rants about things. And he'd ranted about, why people don't get ports from the ITF, and he decided to actually go run the process. He tried for 6969, and they wouldn't give it to him for, I don't know why, right? But he got 2 ports assigned, so there actually are real ports for this thing. And then the sort of phase, sort of, we get back to a known sort of, startup configuration. This particular config file runs PMC stat, so we can actually, this was done back when we were testing PF versus other systems, packet filters. And so we run, PMC stat while we're running, so we can actually see where the time goes. And then when we're done, we go out and collect the results and bring them back to one place, so we don't have to go manually scrape the results off all these different machines. So, we want to do a baseline. We want to figure out how fast things are when we're not probing, when we're not sticking boxes in the middle. We don't have any middle boxes. We don't have any packet filter entries. We don't have anything else. So we use iPerf to do a TCP-based test, and we use PacketGen out of the NetMap project to do high rate per packet per second tests. So we set up, 2 machines just back to back on switch ports, and we run iPerf between them. And, this number looks pretty good, right? On a 10 gig link, we're getting 9.41 gigabits per second. Everything's good, right? We're done. Yeah? Unfortunately, when we turn around and use, the shortest possible packets and send them at a very high rate, sure enough, we can send nearly, I said it was 1.488. We can send nearly a 10 gig link full of packets, but they don't all come out the other end. What happened, right? Because this number is a lot smaller than that number. This is only about 1.1, 1.2 million versus almost 15. So, herein lies the source of the problem. This is why, people say their firewall runs at 10 gig. It's like, really? What if you throw small packets at it? Because all the work is actually in the per packet thing, right? Running the data around inside is easy. It's trivial, right? It's DMA. But taking the interrupt and actually saying, hey, look, I need to do something in this packet. Well, let's dig out the source address. Let's dig out the destination address. Let's figure out what we want to do and run a bunch of logic, right? So TCP finds out what the MPU is, sends packets at that size. You know, if you've got path MTU discovery, even across the internet, the right thing happens, right? Otherwise, we fall back to, 512 bytes. But on a local LAN, you're always running at the MTU. Packet gen runs really short packets, and the shortest possible packet is 64 bytes. And then you've got an interframe sequence that's about another 20 bytes of time, and that's all you get. And if you do the math, you come up with this pretty quickly. But the Ethernet spec says the shortest possible packet is 64 bytes long. So, the device under test here cannot quite keep up. I mean, it's receiving at a tenth of the rate. So, like I said, back in March and May, we did packet filtering. I started a project with the FreeBSD Foundation 2 years ago to figure out how to do ASGCM for IPsec, because I was tired of IPsec being slow. Encryption is computationally expensive because that's how you keep somebody else from reading the traffic, right? You force them to run so much computation that it's not worth their time. It takes them decades to decrypt your packets if you do it right. It's been done for a long time with offloaded coprocessors. Anybody remember the hyphen cards that were real popular in little Socrates boxes? Hyphen's out of business. Anybody know? It's actually bought by a company called XR, but they don't even ship that technology. And these days, with more modern CPUs, you've got AES-NI instructions. You've got the ability to accelerate the AES algorithms using special instructions on modern AMD and Intel platforms, and then the ARM guys have a similar set of instructions. So, again, we're going to do a 2-host setup, just 2 hosts back-to-back on the switch. We're going to use iPerf. So, the very first thing we did is said, okay, I want to measure no encryption, right? Just what's the overhead of the framing and the code path. Turned off TCP offload on the NICs and that kind of thing. And we get about, 2.2 gigabits per second. This is 2 fairly fast hosts, back to back, just running IPsec without any of the actual real overhead. That's okay, right? Does anybody's VPN go at 2.2 gigabits today? So we turn on authentication, right? And this is the only one that we did in transport mode, because typically the only reason to just run authentication is to just assure yourself that the host, you got the data the host sent, right? And all of a sudden performance drops to about 620 megabits per second. Because SHA-1, if anybody go to JMG's talk earlier, SHA-1 turns out to be really hard to accelerate on, standard off-the-shelf CPUs. There are some things coming in future generations of Intel CPUs, but they turn out to be really hard to use in the kernel because they run in the AVX part. And that means you have to save all the state every time. Triple DES so DES is officially deprecated, even though it's still supported in FreeBSD. Just single DES was deprecated years ago, and I'm trying to get it pulled out. But triple DES is still okay. So it basically runs 3 passes over the, using a longer key. This is still in common use. We put this up to show what the performance is of, I think most of the banks have moved off DES now, but some people still use this. So again, we sort of get, 140, 145 megabits per second. This is slow to me, right? So AES has got a couple different modes in it. One is CBC mode. Again, JMG talked about it this morning. This is one of the modes that can be accelerated via AS&I. And you can see the fairly large difference here. Now I'm going to point out that there's a lot of examples for how to set this up. And if you do, you've got nothing. You've made a sort of privacy LAN or privacy WAN out of it. But since you don't have an HMAC you don't have any authentication on, you don't know if somebody's spoofing packets at you. Right? Since there's no HMAC here, this is not a secure way to do it, but, you know, again, it sort of shows that the impact of the ASNI instructions. You go from around 750 megabits to 1.1, almost 1.2 gigabits. And this is sort of what, you know, the acceleration of ASNI. And for reasons that I can't fathom, it's not called AES in FreeBSD. Original is the original name of the guy who submitted the algorithm. So when you turn on authentication, so you actually know that somebody's not spoofing frames at you even though they're encrypted, performance drops a lot. Right? This is even slower than just HMAC, of course, because we're running some additional code, but ASNI doesn't help. And so, you know, when we were doing pfSense and all these ASNI processors started to come along, we turn it on, it's like, there's no benefit here, right? There's no difference, and here it is. Even though we turn ASNI on, it takes so long to run the SHA-1 pass over the packet that you effectively have no benefit. Well, how do you solve this? There's a different mode of ASGM, Galois, I'm butchering the French, counter mode, which basically takes AS and makes a stream cipher out of it. And the additional interesting thing is you get authentication of the data out of the process. So you're not just encrypting, you're also, you have a nonce and you get to also authenticate the data in the same pass. And AES GCM is also much more parallelizable, so you don't have to complete the first block before you can start on the second block. And you can sort of step these, you know, ladder step these all the way through. So we did a big project with the FreeBSD Foundation. They covered half of JMG's where we covered the other half, and then we made all the changes for IPsec. Ermel, Lucy did a lot of the work. We managed to get it in current. We just missed the cutoff for 10.2. I mean, we were there in time, but we were like too big a risk. So we've done an internal merge from current to make sure that we know how to put it on stable, and I'm hoping to get this in 10.3. It'll definitely be in 11. But there's a huge, huge performance gain here, right? We've gone from, you know, I mean, the software alone, it runs at 276 megabits per second, which is faster than triple DES if you don't have ASNI in your chip for some reason. And when you have ASNI on, we're, you know, almost 1.3 gigabits a second, and I think that's a win. I mean, if your external LAN isn't that fast, you're not taking over the whole box just to run the crypto, right? If you don't have as many packets going through per second that have to be encrypted, you're not going to use the CPU to encrypt them. You know, 120-bit runs just a little bit faster than 256-bit. 120 bits sort of, you know, pronounced good enough for now, but we're ready for when it isn't. So overall, you know, here's without any encryption, and we're getting about half the throughput with real encryption and authentication on. Like I said, this code's in the tree. It'll make it into the next release of FreeBSD. OpenBSD has had AES-GCM for a number of years. Linux has it. We were like the only people hanging out without it. The new iOS 9, I guess, has AES-GCM in it. The new macOS, what's it called? It's not Yosemite, it's some, huh? El Capitan also has AES-GCM in it, so. So enough with IPsec. It's a 2-year-long project. I couldn't believe how long it took to actually get it. I mean, the work didn't take 2 years. It's the process. So let's move on to fast forwarding. Anybody run fast forwarding on their FreeBSD router? You guys all asleep? That guy actually is asleep. It's funny. Oh, he woke up. So fast forwarding is like the turbo button, right? There's this code that got put in back in 2003, and I mean, it's interesting, but it also breaks things. And you basically, if you set this syscontrol to 1, you get, the fast forwarding path. So here is, sort of, at 64 byte frame size, we can send, almost a full 10 gig through, but we only get 1 million packets per second out. And that's only 7% of line rate. We're only using 7% of our 10 gig interface. That sucks, right? And, I mean, if you run up to 1500 byte frames, well, that looks good, right? But not all of your frames are 1500 bytes long. And so there's a problem in the middle here. You turn on fast forwarding and the situation improves a little bit. Now we're forwarding at line rate at 1K packets. And we've got a little higher performance here, but down at the bottom it still sucks. Okay, why? Why is fast forwarding better? It turns out you ask this question, nobody can really answer. They just know it's better. So we go off and run dtrace. And we basically measure the time between the packet coming in off the Ethernet interface to the time it runs back out to the NIC. So this is the slow path, and this is the fast forwarding path. So we have both, fewer function calls, and we sort of skip several things. Well, we skip IP input, and we skip IP output. And IP forward is really fast forward is a shorter, simpler version of IP forward. So it turns out that the reason fast forwarding is fast is because it doesn't actually deal with the more complex packets. If your packet has IP options in it, it throws up its hands and says, I can't do this. There's several other conditions, like, the packet is for this box. It throws up its hands and has an escape path to go back to the normal path. So the benefit here is that if you turn on IP fast forward, you're actually making the forwarding decision a lot sooner in time. So, we use conductor to go out and, look at what the time is. And these are buckets, if you will, of 1024 nanosecond time slices. And the main thing to pay attention to is, we get a lot fewer under the slow path than we do under the fast path. Sometimes something takes longer, right? But overall, we get more of them done in a given time quantity. So that's why fast forwarding is fast. And here's the dtrace script that we run under conductor to generate the previous graph. Dtrace is great. It's a really effective tool for actually getting inside the system. And there's a little bit of probe effect you have to watch for, but overall, it lets you set up really simple scripting to go out and find out where the time's being spent. So, fast forwarding isn't free, right? It duplicates a lot of code. If you're running fast forwarding and the packet ends up in the slow path, you don't get any benefit from having run all that code until you made the decision to bail. It's only if you actually get to forward the packet that fast forwarding is of any effect. It also delays reception on the host. So if you've got a web server on the host for some reason, or another application, and you're trying to send data to it, you actually take longer to get to the decision to accept the data on the machine. So I can't actually read that here. So we went off and measured it, and you get about a 4% delta. It's 4% slower to receive data on the machine with fast forwarding on, just because all these decisions take place later in time. And that's, nobody went off and measured this impact before. So we don't want this. This sucks, right? This sucks for pfSense because I'd really like to have fast forwarding on, but it breaks IPsec. I can't have fast forwarding on if my customers want to run IPsec. It also breaks a couple other things in IPFW if you use it exactly the right way. So we went off and re-architected this, right? Why duplicate all this code? Why just run the functions once, save the decision points, you can make a better decision. So now we have one escape clause, right? We can forward this or not. If we can't, we go back into the normal path. And we put this back up in IP input. So now, and I'll put up the comparison graph, it's not quite as fast forward, but it's a lot faster than the old code, the normal path. And so here's the comparison, right? Here's the old code. This is in percent of line rate again. We didn't make any impact here. But once we got to about 256 byte packets, we're sending few enough of them that we almost duplicate the fast forwarding with this new thing we call tri-forwarding. There's really only one anomaly out here, and we haven't had time to go out and find out what that is, but I'm pretty sure it's fixable. And then when you look at packet reception on the box, we're down to just under 2% instead of almost 5%. So that's actually a benefit. Right? We get most of the benefit of fast forwarding, potentially all the benefit of fast forwarding, without the impact of reception on the box. So those changes are all in Fabricator. They're out for review. Potentially they'll get an 11. So this is really, and I'm rushing through this, I'm sorry, but it's, I can fill in all the details if you want. Like I said, we started this in spring for Asia. We talked about PF back then. We're always sort of looking at where else in the stack we can go off and actually look at where things are slow or how we can improve them. We've presented this at every BSD conference so far this year. We'll branch out and start to cover more subsystems because there's a lot of other places where the networking is not as good as it could be. And then we're giving the same talk at BSDCon Brazil next week. So I do have one more thing to show here, and it's a bit of a sneak peek. So you can get all this, it's all in GitHub, including all the scripts and results that were used in this talk. So you can go out and you can go out and reproduce this if you want. You can use this for your own needs. PSN sort of paid for the work here, so that's really the only reason that's in there. And then this book, if you're interested in this kind of thing, this book is the authoritative source on how to do benchmarking. And it was, I think, last printed in like 1992. If you go out and try to buy it on Amazon, it's a lot of money. But there's a new edition coming out. I think it was supposed to be out in September. I haven't received my copy yet, but there's actually a brand new rewrite of it coming out from the same guy. And if you're interested in this kind of thing, you need to get a copy of this book and look at it. So this is the thing that's going to get talked about next week at in Brazil. So we've, in the process of looking at all this stuff and this million packets a second, even on a fast box, that million packets per second forwarding was done an E3 running at 3 gigahertz. I mean, that's a lot of box to put into a router or a firewall, right? So we took Luis Sousa, Luz, took the fast forwarding code and he ran it over NetMap. Everybody know what NetMap is? Luigi Rizzo, kernel bypass networking. You take and map the rings from the NIC into user space, and then your program actually has access to the rings so it can pull packets directly off the NIC. So you get a pipe, if you will, that sort of runs around the whole kernel stack, and you can do processing of raw frames in your program. So we took the fast forward code from 10, and we wrapped it up with some libevent and that kind of thing. And it's like libuinet, which is the FreeBSD stack in user space over NetMap, but this is only for forwarding. It's only for routing, if you will. It's only single-threaded. We haven't done any multi-threading here, other than sort of the event-based stuff we get out of libevent. And it's still the FreeBSD stack. There's no perturbation on what actually happens in the forwarding code. So FreeBSD is a single packet at a time run to completion architecture in the network stack. It runs just as far as it can on every single packet, and there's only one packet in flight, if you will, at a time. So this is what we get, and this is actually, I think, pretty exciting. Because this little box is a little tiny 2-core atom, right? I mean, I have one of these for sale for less than $300. And this is this is forwarding, this is fast forwarding, this is try forwarding, and this is what happens when you punt it all into user space, right? And that's a huge difference. It's like 6x. And it was like, you know, then we got curious and started running on different hardware. So the only difference between this box and this box is, you know, this is 8 cores, but it's really clock rate. And if you go out and actually divide the numbers here, it's almost exactly the same ratio as the clock rate. So it's just we get to run more, right? This Xeon D, the big difference between these two is not necessarily clock rate, it's that the Xeons can do more per clock. They have a lot more efficient, you know, memory system. They've got better caches. They have a lot of additional instructions. And again, it's, you know, this is twice what FreeBSD can do on any size box that I care to spend money on. And up here, you know, I just got the result last night. This is 5 million packets a second. This is a third. These are 64-byte packets. This is as bad as it gets. This is 5 million packets a second. We're at a third using 1 core. And this box has 4 cores, and that one has 8, and that one has 8, and that one has 2, right? So, you know, this is going to be open sourced, be BSD licensed. We will, you know, complete the rest of this. It doesn't do V6 right now. We'll add V6. And then, you know, there's some additional ideas as well. But without doing the science of knowing where you're coming from and being able to run the experiment, you have no idea if you've got a better result. And so Conductor is really about doing science. You know, establishing a baseline, getting a result, potentially making, you know, thinking about things, making some changes to the system, and then finding out if you actually made things better or worse. So the idea here, and there's other people working on this in the community, is to start doing sort of continuous testing of the stack to find out if we're creating problems for ourselves. That's everything I've got. I mean, I'm open to questions, but really? Nothing? Okay. No, this is all basically out of the box. So, you know, doing any kind of tuning, I mean, there's not a lot of tuning to do for forwarding, right? Running around, you know, socket buffer sizes doesn't do anything for you, right? And FreeBSD is actually pretty good at self-tuning in a lot of situations for packet reception. So, no, but you could definitely test to see if you had a result, right, using this. Yeah. Yeah, there's no tuning at all in here. What IPsec software? This is all on FreeBSD. Oh, this is all statically keyed. If you go out and look, it's all just you know, PF key in the top. pfSense runs Strong Swan, so there's a camp and IV2 implementation there. But that's just keying. By the time you drive the keys in the kernel, and this is all just measuring the kernel performance, it's all the same. Yeah, this is just the NICs that are on the system, right? And this is just what we got. This box, I mean, it's got 4 1-gig NICs on it, but we didn't use them here, and we just happened to have put a T520 in a Chelsea NIC. The effect here is not the style of NIC, although the Chelsea NICs have an interesting misfeature in them. One of the things we've recently done with NetMap Forward is put the host ring back in. So we actually have a slow path again. right? If the packet is forwarded, normally if you run these user space kernel bypass things, you lose the ability to actually do anything with it in the normal, the kernel and socket layer. But NetMap has a host ring per interface, so you can re-inject the packet and it goes back through the stack the normal path. And you actually can take things out the other way and do what you want with it. You can take things off the kernel stack and run them back through NetMap, and it's like divert sockets on steroids, right? But we put the host ring back in. Well, the Chelseo NetMap driver doesn't have access to the host ring. So one of the reasons why a lot of the testing is actually done on the Intel NICs is because we actually have full access there. The Chelseos are actually where there's a different interface name for the NetMap interface versus the non-NetMap interface. So when NetMap Forward comes up, you tell it which interfaces to deal with, and it just takes over. Right? It puts the interfaces in NetMap mode, uses all the same addressing information that was already there, so you can just configure this like you're configuring a FreeBSD box. And then you run NetMap Forward and tell it, run these 2, 4, however many interfaces, and it just takes over. If you stop it for any reason, the normal path takes back over. So if if there's a bug and it dies or you stop it, it just goes back to what was running before. So it's very easy to develop on, right? You don't have to, I'm actually pretty interested in DBDK, but when you run DBDK, there's all this sort of extra work you have to do to get DBDK to run. This is trivial, right? Anyone else? Yeah.
What was the name of the book? How was it kind of slow to photos?
Go ahead and take the photo. I mean, it's really, Rajan is the author, and if you just go Google for that, it'll pop up right away. Is that it? Look, you can go home early, or drink early. Right?
Great, thanks.
Swedish fish bread.
Okay, cool. I just have to figure out how to get it home. Yeah, well, it is kind of brittle. That was good. Yeah, I always go fast.
Yeah, we did go fast, but I mean, the numbers.
I've been doing this for years, right?